Hello students, a warm welcome for this AIATS plus discussion. So today we'll be discussing your solutions for the exam that happened on 17th January 2026. So this is test number 2. Now first, before we start discussing the solutions for this, because whatever you people have already attempted, so we have a result that clearly reflects. So few questions are attempted very concept wise these are very much clear to everyone, so these are attempted very well by most of the students, but there are only few questions, few areas which you people have attempted wrong. So that may be because of your conceptual understanding of the topic, or maybe because of some numerical calculation error, or maybe because of some sort of gap in knowing the formula, whatever the reason may be. So we'll be covering up all, and that would help you to really perform well in your NEET 2026. So before we start, let's understand what is this AIATS plus. So this plus stands for Personalized Learning for Ultimate Success. So this series has been specifically designed for the students who need some personal attention for all India exams. So that is how we have come up with this AIATS plus. So that is for Personalized Learning for Ultimate Success. So this is the one. So Rishabh, very good morning. Then M Sharma, sir, my app is getting an error, the result is not opening, it still showing start test when I have already attempted. Sharma ji, I would rather suggest you please connect with your branch or your contact person, or the number whatever is there for getting the support. So here I won't be helping you much on all these technical guidance, but I can suggest you where to approach. So you better approach your listed number or your listed contact details there. So let's start. Now the very first question, what this question says: in a region the intensity of an electric field is given by E is equal to 2 I cap plus 3 J cap plus K cap in Newton per coulomb. The electric flux through the surface S, that is 10 J cap meter square in the region S. Now first, before you attempt this, let's build up some basics of this. So electric flux so that is written as phi. So this is mathematically understood as E dot A, where E is your electric field vector and A is your area vector. So this is, as you can see, this is a dot product. So flux is a scalar physical quantity. Got it? Now there are few important aspects which you need to understand before you go and solve this. So it involves dot product. So what is the physical significance of this flux? So as you can understand it from this, this is E dot A. It means how many electric field lines are passing through the given area of observation, that is called flux. So that quantifies the electric field line. So this is how you understand the physical meaning of this word flux. So it involves E dot A. So before you, so let's understand A dot B. So A dot B can, this is a dot product of two vectors A and B, which are inclined at some angle. Let's suppose this is your A, this is your B, so they are inclined at some angle theta. So A is also a 3D vector, B is also a 3D vector. So when you multiply this A dot B, you end up with AX BX AY BY plus AZ BZ. So this is the dot product of two vectors in terms of components x and y. So AX BX plus AY BY plus AZ BZ. So that is how you write down the dot product. Now coming to this, so this question says E dot A. So we have electric field vector. So this is 2I cap plus 3J cap plus K cap dot. Now for the area vector, you have only 10J cap. It means the x component and the y component is there, rather the z component or the z component, it's not there for the area vector that is represented by this S. So this is the dot product for these two vectors. Now AX BX, so AX is 2, BX is not there, so we'll keep it as 0. AY is 3 and BY is 10. AZ is 1 and BZ is, again we'll keep it as 0. So when you multiply it, it gives you the numerical value as 30 only. Now flux is E dot A. So if you write down the units, SI units, so this is Newton per coulomb, that is the SI unit for the electric field, and for the area vector it is meter square. So 30 Newton per coulomb into meter square, that is the exact answer we have. Any doubt from this part? Any doubt? So we have now students coming up very fast. Yes, Ashish Kumar. सर 2026 के लिए JEE मेंस का PYQ करना चाहिए या नहीं? It's your personal choice. If you want to give a real challenge to your subject knowledge, you can go ahead with that. There is no harm in it. Then aiming for AFMC, Ashish कर लो, but 5 years के more than enough है. Yes, that again depends on your level of appetite you have. If you have a bigger appetite, अगर आपका hunger बड़ा है, तो you can go ahead with varieties of exams, varieties of papers, PYQ maybe for 5 years, 10 years. That depends on your level of preparation. And Ashish Kumar, okay. Nidhi, good morning. M Sharma, Shubham Silawat, once again explain, sir. Okay, Shubham. This is quite easy. Electric flux is understood as E dot A. So this is the mathematical expression for your flux, and because this is a dot product, so we call it as a scalar physical quantity, and this is understood as how many electric field lines are passing through your given area of observation. That is electric flux. Flux का meaning क्या रहता है बच्चों? Flux means flow. And here we are talking about the flow of electric field lines through a particular area of observation. That is how you understand this. So because this is written as E dot A as a dot product. So just to help you understand the dot product, A dot B, if you have two vectors A and B inclined at some angle theta, then in terms of components A dot B can be written as AX BX plus AY BY plus AZ BZ or AZ BZ. So going by the same fashion, what we have done is हमने यहाँ पर इसका numerical value E का in terms of vectors or area vector in terms of its component, we have just placed it, and putting all the values in this will have the required answer as 30 Newton per coulomb into meter square. Yash Raj sir, what about the 10J cap? अरे 10J cap ही तो हम लोगों ने यूज किया बेटा. It's what is this? AY is what? 3. BY is what? 10. You got it or not? Now any doubt from this part? So we got the answer as 30 Newton meter square per coulomb. So let's verify it. Yes, so this is perfectly fine. Now let's suppose if I give you one more numerical based on this. This is for your practice sake. Let's suppose electric field vector, we keep it as 2I cap plus j cap plus k cap, and this is Newton per coulomb. And for the area vector, we simply keep it as, and this is meter square now. Got it? Now, so this is your area vector and this is what you have assumed it as your electric field vector. Now, if I ask you to find out flux for this data, this numerical value, this condition. So again, going by the same fashion, we'll simply keep it as AX plus AY plus AZ. So what is EX? EX is 2. What is AX? AX is 1. What is EY? EY is 1. What is AY? AY is minus 1. EZ is 1 and this AZ is also 1. So this becomes minus 1, this becomes plus 1, this goes, and finally you are left with only 2. So that is the numerical value of the flux, and unit wise it is again the same, Newton per coulomb for the electric field into area meter square. So that is another example or another numerical practice for you. Got it or not? Now let's suppose now you have two vectors. Got it? And they are inclined at 60 degree to each other. Now we have to find out the flux for this, and the numerical value, the magnitude of electric field is, let's suppose 10 Newton per coulomb and area 2, so it gives you 25, and unit wise SI unit again Newton per coulomb into meter square is the SI unit for this. So we have another variety for the same numerical flux. Any doubt from this part? So Yashveer Yogi got the thumbs up, then Rishabh got the right answer, Shubham got the right answer, and Sharma ji also got the right answer, 25. Good, great. Any help from this part now? Then we have Maxwell I7P. Hello sir, lots of love from North India. Array, good, great, thank you. So Faiza, so there is no doubt. So I think we should move on. So this was the same question we attempted. Now moving to the next question. This is again electric current based question. It says a steady current flows in a metallic conductor of non-uniform cross section. Okay, the quantity or the quantities remaining constant along the length of the conductor. Okay, fine. So we have a conductor and that is of non-uniform cross section. So let's keep it like this. Got it? So definitely when you say it's a non-uniform, so area of cross section at this point may be A and at the, A1, and at the other point it is A2 only. You got it or not? Now we have to comment on certain parameters: current, electric field, drift speed. Okay, fine. Now current, because this is the same conductor, so whatever current you allow at this point, the same current will be observed at this point, because that is the same. You have only one path, one passage. There is no splitting or there is no division of the current, because current has only one path, though uniform cross section is not there, but the current will remain same. So whatever current you have at this point, the same current will be at this point. So current wise it goes the same one. Got it? Now you have another factor that is called current density. Current is a scalar quantity, though it has magnitude, it has direction. But why it is scalar? That is again very important, because it does not obey your vector addition laws or parallelogram laws or whatever the vector addition laws are there. So it's not following all those laws. So that is why we place current as, we call it as a scalar one. But now we have J, that is current density. And as you can clearly see, current density we are calling it as a vector quantity, and this is current per unit area. Got it? As you can see, A1 is smaller than A2. क्या हमें A2 बड़ा नजर आ रहा है? Now look at this, current density is inversely to area because current is same. So अगर हम यहाँ पर करंट डेंसिटी को J1 और यहाँ पर J2 कॉल कर लें, करंट डेंसिटी इज अ वेक्टर क्वांटिटी. एरिया कहाँ बड़ा है बच्चों? 2 पर. अगर 2 पर एरिया बड़ा है तो करंट डेंसिटी क्या होगी? स्मॉल होगी. सो करंट डेंसिटी 0.1 दैट इज द एट दिस. सो J1 जो है यहाँ पर करंट डेंसिटी क्या होगी एज कंपेयर टू द अदर एंड? So J1 would definitely be more than J2. यहाँ तक कोई डाउट? ओके फाइन, क्लियर है. नाउ सेकेंड वन, हमें यहाँ पर कांस्टेंट बताना है. ठीक है, करंट तो कांस्टेंट है, वी गॉट दैट पार्ट. अब देखते हैं इलेक्ट्रिक फील्ड. क्या इलेक्ट्रिक फील्ड कांस्टेंट हो सकता है? अब E times, oh sorry, sigma times electric field is current density. So this is another important formula we have. अब अगर आपका करंट डेंसिटी J कांस्टेंट नहीं है, कैन यू आइडेंटिफाई दिस सिंबल? Sigma. Sigma stands for conductivity, which is a material dependent constant. Got it? So this is also constant. लेकिन अगर J आपका constant नहीं है तो क्या इलेक्ट्रिक फील्ड along the length constant होगी? नहीं होगी. तो इलेक्ट्रिक फील्ड is not a constant parameter in this. Got it? So how we are getting close to the answer? I think you people are getting it. Now let's come back to the third, drift velocity. Current same है. So do we have an idea about the relation between current and drift velocity? So this is written as NEA VD. VD stands for drift velocity, where small n is number density, that is number of free electrons per unit volume. E is charge, A is area of cross section. Now for a given material, for a given conductor, N क्या है बच्चों? N fix है, number density is fixed. If I give you a copper maybe of varying cross section, तो number density तो उसकी fix होगी because that is copper. E charge on electron 1.6 into 10 raised to power minus 19 coulomb, that is also fixed. Current is also fixed. So at this point, if I call it as drift velocity or drift speed as V1, area of cross section is A1, and at the second point it's A2 V2. You got it? So this is like equation of continuity. So A1 V1 is equal to A2 V2. आप देख सकते हैं अगर A2 बड़ा है, A2 is more than A1, तो डेफिनेटली इनका प्रोडक्ट कांस्टेंट है. अगर A2 बड़ा है तो V2 क्या रहेगा बच्चों? दैट वुड बी स्मॉलर देन V1. इसका मतलब drift speed is also not constant at this point and at the other end of the non-uniform conductor. So this is also not your correct option. तो ये option पूरी तरह correct नहीं है, इसमें सिर्फ एक part है, so this is not the option. Drift speed only? No, this we have just proved. Current and drift speed? No, क्योंकि current है लेकिन drift speed नहीं है. And current only? Yes. So this is the complete answer and this is best option you have. It is the current only that is constant, that remains constant all along the length of the conductor of uniform cross section. Now any doubt from this part? Any doubt? Shubham, Faiza, Sharma ji, any doubt? Maxwell, so shall we move? Okay, Rishabh, good. So I got a thumbs up from Rishabh side also. So I think we should move on. So let's check it from the answer slide. This is current only. Now moving to the next question. Next question is also quite interesting. Two capacitors of capacitance 2 microfarad and 5 microfarad are connected across a 7-volt battery in series as shown in figure. So we have two capacitors 2 and 5, they are in series. Now when they are in series, if I ask you what is the equivalent capacitance for these two and when they are connected to a 7-volt. So equivalent capacitance, let's suppose if I ask you equivalent capacitance, so for the series combination, equivalent capacitance would be calculated like this. And what is C1? So this is 2 micro, this is 5 micro, and this is 7. So that becomes 10 by 7 microfarad. Got it? Fine. So this is the equivalent capacitance. Now, what is the charge stored when you have the equivalent capacitance? So using Q is equal to CV. So what is C? Equivalent C. And what is V? Applied V is 7 volt. So that becomes 10, and that is micro is there, micro coulomb. So this is the charge we have. So we have this is positive, so this is plus 10 micro, this is minus 10, this is plus 10, this is minus 10, and so on. So this is and so on means that is all we have. Any doubt from this part? Now after a long time, okay, once they are fully charged, so this is the final condition when you have a battery connected with this. After a long time the battery is replaced, so we remove the battery and just replace it with a closed switch. So this is something like this. So we have C equivalent and this is the switch you have. Got it? So this is the simplest circuit we have. The common potential across the two capacitors is. Can you see? This is like something called short circuiting. Got it or not? What is the final charge? Minus on this side, plus 10 on this side. So when you are doing it as a short circuit, so what is the final potential or final charge you have? So short circuiting will lead to the zero charge finally, because minus 10 and plus 10, and the potential would also be 0. So this is the condition you have. Any doubt from this part? Answer is 0. Very fine. Shubham also got the right answer. Rishabh also got the right answer. Good. Any doubt? Okay. So, Bharat Kaushik also just responded. Yes. Maxwell has also given the right answer. Good. Keep it up. Good. So, 0 is the option. Let's check it. Yes. So, shall we move? Now, the fourth question. What it says? A circular coil of radius 6.28 centimeter having 100 turns carries a current of 3.2 ampere. The magnetic field at the center of the coil is. Fine. So, let's suppose you have a circular coil of radius r. Got it? First, we'll try to understand in a very generalized way, very generalized, so that you actually gain the concept. And let's suppose it carries current like this. This current is I, and this is in anti-clockwise fashion. Got it? Now, you just consider a small element over here. This is dl element. Now, you apply your basic, the very first law, how to find out magnetic field for a small current carrying element, that is your Biot-Savart law. And it says small magnetic field is mu naught by 4 pi I dl sin theta by r square. Got it? Now, this is the small element and this is the direction of the current. What is this angle is? 90. So, sin 90 becomes 1. So, we'll omit this sign. Now, to find out complete, we'll just integrate it, but we know this is something what you call it as a vector physical quantity. So, as per the law, this is what? It is coming out of the plane. When you say it is out of the plane, we'll simply put it as outside the plane as dot. Had it been inside the plane, we could have placed a cross over there, that is inside the plane, as per your this rule. Now, mu naught is constant, 4 pi is constant, I is constant, and this is r square, and you just integrate this dl part. So, when you integrate this dl, so it becomes the complete circumference 2 pi r. So, it becomes mu naught I by 4 pi r square into 2 pi r. So, this 4 pi and 2 pi gives you this 2, this r goes with this r. So, it becomes mu naught I by 2r. So, this is the actual magnetic field at the center of this, and it is outside the plane. It's coming like this. Got it? Any doubt from this part? So, this is the expression we got it using your Biot-Savart law, and this is a very simple expression. Any doubt from this part? I hope this is clear to everyone. Now, this is for one circular turn. So, magnetic field at the center is mu naught I by 2r, and if you have n number of turns, So we'll simply keep it as into N, and that gives you the total magnetic field, and this is in terms of magnitude. Got it? I'll give you the rule to define the direction also. Let me just conclude this part. So what this mu naught, क्या होती है बच्चों mu naught की वैल्यू? This is 4 pi into 10 to the power minus 7 multiply by current. What is the current? 3.2 N. So it has 100 turns into 100 by 2 into R. What is this R is? 6.28 centimeter, and we'll keep it into meter. So while calculating all the variables, you need to be very sure about your conversions if you have any. So हमें सारे यूनिट स्टैंडर्डाइज फॉर्मेट में रखने हैं, और अब अगर हम इसको कैलकुलेट करते हैं, so what it becomes? This becomes 2 into 3.14, so that gives you 6.28. So this goes with this 6.28. It goes with what? -5, and it goes with this, so -3. So it's 3.2 into 10 to the power -3, because this is magnetic field, so unit wise टेस्ला. क्या आप कोई और यूनिट बता सकते हैं मैग्नेटिक फील्ड के? टेस्ला के अलावा, इन एडिशन टू टेस्ला, डू वी हैव एनी अदर यूनिट्स फॉर द मैग्नेटिक फील्ड? बता सकते हैं बच्चों? एंड इट्स वेबर पर मीटर स्क्वायर. सो आई थिंक we got the answer, 3.2 into 10 to the power -3 Weber per meter square. Good, Rishabh, very good. Keep it up. Shubham also gave me the right answer. Now, this is the one. Now, coming back to the direction part. Now, let's suppose you have this circular coil and you have another circular coil. In one coil you have a current I, and that is in clockwise fashion, and in the second one you have current I in the anti-clockwise fashion. Got it? Now, how you define the direction for the magnetic field? So first you try to understand, if you have a loop like this, if you have a current carrying loop, current is in clockwise fashion. So एक पॉइंट बिल्कुल क्लियर रखिए कि अगर इस कॉइल में करंट पास हो रहा है, दिस कॉइल वुड बिहेव लाइक अ मैग्नेटिक डायपोल, और सिंपल भाषा में एक मैग्नेट की तरह ये बिहेव करेगा. अब अगर ये एक मैग्नेट की तरह बिहेव करेगा, तो वी नो मैग्नेट हैज टू डिस्टिंक्ट पोल्स. एक पोल को नॉर्थ पोल बोलते हैं, एक पोल को साउथ पोल बोलते हैं. सो व्हेन यू हैव करंट इन दिस फैशन, क्लॉकवाइज फैशन, यू गॉट इट? सो यहाँ पे वी हैव साउथ पोल, और इस कॉइल के नीचे बनेगा नॉर्थ पोल. ट्राई टू विजुअलाइज इट हेयर. सो इफ यू हैव अ करंट कैरिंग कॉइल लाइक दिस, तो यहाँ से जब आप देखेंगे तो यू विल फाइंड साउथ पोल अबव दिस प्लेन एंड नॉर्थ पोल इज बिलो दिस प्लेन. ये पॉइंट क्लियर है? सो इफ यू हैव अ करंट इन द क्लॉकवाइज फैशन, यहाँ कौन सा पोल नजर आ रहा है मुझे? साउथ. यहाँ कौन सा नजर आ रहा है? नॉर्थ. एंड दिस बिकम्स अ कंप्लीट मैग्नेट, और वी कॉल इट द मैग्नेटिक डायपोल. गॉट इट? और हमें ये भी पता है कि जो हमारी मैग्नेटिक फील्ड लाइंस हैं वो नॉर्थ से ओरिजिनेट होती हैं और साउथ में टर्मिनेट होती हैं लाइक दिस. यू गॉट इट? सो अब देखिए साउथ ऊपर है, नीचे नॉर्थ है, नीचे से मैग्नेटिक फील्ड लाइन नॉर्थ से बाहर आ रही हैं और ऐसे साउथ में अंदर की तरफ जा रही हैं. सो इट इज इनसाइड द प्लेन, इन द प्लेन. सो इट्स कमिंग डाउनवर्ड, इनसाइड और इन द प्लेन. नाउ इन द सेकेंड सिचुएशन, अगर यही करंट एंटी क्लॉकवाइज फैशन में है तो एंटी क्लॉकवाइज फैशन में ऊपर मुझे क्या नजर आएगा? नॉर्थ पोल. नीचे क्या नजर आएगा मुझे? साउथ पोल. तो अगर ये एंटी क्लॉकवाइज फैशन है तो यहाँ नॉर्थ पोल नजर आएगा और नीचे क्या नजर आएगा? साउथ पोल. मैग्नेटिक फील्ड लाइन नॉर्थ से निकलेंगी बाहर और ऐसे साउथ में. सो मैग्नेटिक फील्ड नॉर्थ से बाहर निकलकर साउथ में, एंड दिस इज हाउ द मैग्नेटिक फील्ड would look like, and this is out of plane. तो हमने यहाँ पे दो पॉइंट्स नोट किए कि मेरी मैग्नेटिक फील्ड लाइंस मुझे कैसी नजर आएंगी अगर मेरा करंट क्लॉकवाइज या एंटी क्लॉकवाइज फैशन में है. दूसरा इंपॉर्टेंट पॉइंट कि अगर मेरे पास ये कॉइल XY प्लेन में है तो मैग्नेटिक फील्ड Z एक्सिस पर लाई करेगी, नॉर्मल टू द प्लेन. गॉट इट? तो हमने यहाँ पे दो पॉइंट्स नोट करने हैं. एक कि ये क्लॉकवाइज और एंटी क्लॉकवाइज फैशन में हाउ यू डिफाइन कि जो मैग्नेटिक पोल्स हैं वो कहाँ बनेंगे, और फील्ड जो है वो हमेशा नॉर्मल टू, जो फील्ड है वो हमेशा नॉर्मल टू प्लेन ऑफ द कॉइल रहेगी. तो अगर मेरी कॉइल XY प्लेन में है तो मैग्नेटिक फील्ड कहाँ रहेगी? Z एक्सिस पर. अब डिपेंडिंग ऑन द डायरेक्शन ये ऊपर भी हो सकती है, नीचे भी हो सकती है, डिपेंडिंग ऑन द डायरेक्शन. अगर मैं YZ होगा तो मैग्नेटिक फील्ड कहाँ होगी? X एक्सिस पर, अगेन अबव द प्लेन, बिलो द प्लेन. अगर ये XZ प्लेन है तो मैग्नेटिक फील्ड कहाँ होगी? Y एक्सिस पर, अबव द प्लेन, बिलो द प्लेन. आई होप दिस इज क्लियर टू एवरीवन. So Sharma has given me great bro, very good, nice compliment. And Mr. Harsh, you okay, good. Sir, please speak English. I can't understand Hindi. Okay, no issue, no issue. Inward and outward respectively. Yes, in the plane, out of plane. So can be written as inward and outward. I hope with this concept we are clear about this part also. Any doubt? Okay, Maxwell, I'll speak in English. Don't worry. Don't worry. I got your message. Thanks for this feedback. I think now we should move on to the next. Okay, so that was the question and we got the right answer for that. Moving to next. A charged particle moves in a circle perpendicular to magnetic field. The time period of revolution is independent of. Fine. So let's build up this concept. So you have a charged particle. It's moving with speed v, entering into a uniform field region B, and it experiences a force, and this magnetic force is given to you as QVB sin theta, where theta is your angle between velocity vector and magnetic field vector. Got it? So this is the prime concept you have. This can also be written as Q V cross B in vector form. Now what is there is, first a charged particle is there. It enters a perpendicular, so when theta is 90 degree. Now I would like you to understand why it will move in a circular path. So we know sine 90 is 1, and that gives you the maximum magnetic force, and this magnetic force maximum is given by QVB. I think this is clear to everyone. Now let's understand how it moves in a circular path. So let me draw some of the basics. So we'll assume magnetic field is downward. So this is B. Got it? And here we'll assume your charged particle Q having mass M is moving with this velocity vector at this point. Got it? Now try to understand. So F is equal to Q V cross B. I'll help you to understand this concept from the cross product point of view, which is quite easy. Now let's give direction to your velocity vector. So this is, I'll take it as J vector, and this is inside the plane. So this is a normal one. So we have already considered a perpendicular or a normal magnetic field. So this V is along J and your B is along minus K. So when you define the cross product, J cross K I, but with minus, so it gives you minus I. So the direction of force is minus I. So can you understand? This is the force, and it gives you the turning effect. It gives you the change in the direction of velocity vector. Now let's assume your charged particle may be at this position. So this is the velocity vector. So this is maybe at point of observation P, and let's observe this point Q now. So at Q, velocity vector is minus I, and this B vector is still downward. So this is still in the normal or the perpendicular field. So what is this I cross K? Minus minus neutralize the effect. What is I cross K? Minus J. So I hope you understand this cross product, and this is the direction of the force. Similarly, when you observe at this point, the direction of force would be like this. So what you are observing, at every point the direction of force is such that it gives you the change in the direction of the velocity, or it gives you the concept of circular path. So this maximum force QVB will provide you the necessary centripetal force to this charged particle. Got it or not? Any doubt from this part? So this force QVB provides you necessary centripetal force mv square by r, where m is the mass, and now we'll keep r as the radius of this circular path. Got it? So this is also v, so we'll have the expression r from this one, and this is mv by qb. This r radius of this circular path, or we simply call it as its trajectory also. We call it as its trajectory also. Got it? Now, so we know that when a charged particle enters into a uniform magnetic field perpendicularly or normally, it follows a circular path and its radius is mv by qb. Now, because this is now in circular path, so we can easily calculate its time period, time taken by the particle to complete one round, and that time period we keep it as 2 pi r by v. And when you put the value of r over here, so what you will have 2 pi m by qb. Got it? 2 pi m by qb. Now, It depends on mass, it depends on charge, it depends on B. Coming back to the same question, it depends on magnetic field, because time period I should write it over here also, 2 pi m by QB. So it depends on magnetic field, yes. It depends on the charge particle, yes. It depends on the mass of the particle, yes. But independent of what? Independent of velocity. So this is the correct answer we have for this question. It is independent of velocity. Got it or not? I would like to highlight few more things, because this is moving in a circular path, because it has entered normally or in perpendicular. So its speed is not changing, whereas its direction is changing. Got it? So velocity is changing because of the change in the direction. Its momentum is changing. Got it? But its kinetic energy remains constant. Work done is not there. So I hope you have understood it thoroughly well, and we have added very important aspects to the same situation. What other areas can be asked from this? So velocity of the particle is the correct choice, which is time period is independent of. Any doubt? Speed is kinetic energy is constant, yes, because speed is constant, so kinetic energy would remain constant. I think Sharma ji, you got the answer. Okay. Now, any doubt? Shall we move? Okay. The next question is, magnetic field due to a bar magnet of magnetic dipole moment M on its axial position will be. Fine. So you have a bar magnet. Got it? Let's suppose we call it as its north pole, we call it as its south pole, and this is the magnetic axis, whereas this is the geometrical axis. Any line passing through the center, this is called its axial line. Now, south to north, so its dipole moment is like this, south to north. Fine. Now we have to observe magnetic field on axial line. So let's suppose this is the point P. If this dipole may be of small length 2a and this is at distance r. So at point P, magnetic field due to this north pole would be radially outward, but for the south pole it would be radially inward, because north is closer to point P, so the net magnetic field is like this. Any doubt from this part? I hope this is clear. Now, question is, we have to find out the direction of magnetic field. So it is in the direction of M. Look at this, M is also directed like this, B net is also directed like this. So definitely they seem to be in the same direction. Let's check the other option. In the opposite direction of M, no. Perpendicular to direction of M, no. Make an angle theta, no. So what is the correct option you have? It is in the direction of M only. Got it or not? We can find out for small magnetic dipoles. This B net can also be written as mu naught upon 4 pi 2 m by r cube. So this is the numerical expression. If I keep M as vector, B net as vector, so they are in same direction. So this is the complete in vector notation. Shall I give you something more to it? Had it been a point on its equatorial line, again at a distance. So if you consider a point P on its equatorial line, that is perpendicular bisector, then for this north pole the field would be like this, for the south pole field would be like this, and this is the B net. Got it or not? Simple in terms of direction. Whereas M is still, for the same magnet, M is still in the same direction. So this is, so in this situation, B net is opposite to what? M. This is the point to be noted. Had it been an equatorial point, then B net would be in the opposite direction of M. So in that situation, second option would be the correct option. And if I give you the numerical value for this B net, so it's mu naught upon 4 pi M by R cube. Now, if I keep M as vector and B net also as vector, then I need to keep negative sign, reason being they are opposite to each other. So I hope in the same situation we have attempted the second numerical also. Any doubt from this part? Shall we? Triveni, Chaudhary, okay, good. So now moving to the next question. So that was the answer in the direction of M. The potential differences across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in an LCR circuit. So we have L, C and R. So potential difference across resistance, capacitor and inductance. So these values are given to you. So for the resistance part, it is 80, fine. For the capacitance part, it is 40, and for the inductance part, it is 100. So I hope this numerical situation. Now let's understand it with the help of phasor diagram. So this is VR, this is VL and this is VC. So VR is 80, VC is 40 and this is 100. Got it? So as you can see, VL and VC are opposite, so the resultant of these two would be like this. So that means VL minus VC is what? 60 volt only. Got it? So in this situation, the resultant would be somewhere like this. And clearly, because VL exceeds VC, so this would be in the net inductive circuit and EMF leads current by some angle phi. Got it or not? Complete this. This is the impedance triangle. Now, so we have understood this much. The power factor of this circuit is. So we have to comment or we have to find out the power factor for this. So what is this power factor is? Now, power factor we know is cos phi, where phi is this, what the EMF is leading. So it's the angle with which EMF is leading with respect to current. Now cos phi is what? So look at this triangle. So this is phi. So cos phi is base by hypotenuse. You got it or not? So what is the base? Got it? And what is this hypotenuse? So this is V, which is VL minus VC whole square plus VR square under the root. And when you put the values, VL minus VC is 60. .8. Any doubt from this part? Surely well? Good, Sharma ji. So shall we move? Okay, 0.8 is the correct option. Now, the next question says, a coil having area of 4 meter square is placed in a magnetic field which changes from 3 Weber per meter square to 8 Weber per meter square in an interval of 4 seconds. The magnitude of average EMF induced in the coil. Now, first, this is based on your Faraday's law. The magnitude of induced EMF is d phi by dt. So that means rate of change of flux. Or when you are writing it as rather average. So for the average part, I think we should keep it like this, the total change in flux by the total time, because this is, we are finding it as average. So total change in flux by total change in time. So we know flux is B dot A, which can be written as BA cos theta, and for the maximum value cos theta can be written as 1. So simply we'll keep it like this. So here area of the coil is kept constant, and what is the change in magnetic field? That gives you the change in flux upon change in time. So B2, it changes to the final value 8 and from the initial value 3 in a time interval of 4 seconds. So that gives you precisely as the 5 volt as the answer for this average EMF. Any doubt? Any doubt from this part? This is purely based on your Faraday's law that clearly says the magnitude of induced EMF is rate of change of flux with respect to time. And here, how we are changing the flux? We are changing the magnetic field. Area keeping the constant. So it's only the magnetic field that is there. Change is there. Any doubt? Bharat, Rishabh, Sharma ji, Triveni, any doubt? Maxwell? Fine, 5 volt. Now, in an apparatus, okay, the electric field was formed to oscillate with an amplitude of 18 volt per meter. The amplitude of oscillating magnetic field. Got it or not? Can you correlate exactly when you have oscillating? Oscillating means time varying. Got it? So its position is varying with respect to time. So when you have a time varying oscillating electric field and simultaneously you have a time varying magnetic field, so it means we are talking about an EM wave. Got it or not? So हम किसकी बात कर रहे हैं? We are talking about EM wave. Got it or not? So when we are talking about EM wave, because there is clear hint is there. We have electric field oscillating and we have a magnetic field which is also oscillating. So EM wave is a transverse wave. So if wave is propagating with some speed v, then electric field may be along y-axis and magnetic field may be along z-axis, and both fields are oscillating, and it may have vice versa also. So we need to understand 2-3 important points over here. So when you define the velocity vector, so we write it as E cross B. This is the first point. So all three are mutually perpendicular to each other. This is the first point to be noted for this. Second, when you are writing electric field, so what is the equation for the oscillating electric field? So we'll keep it like this: E naught sine omega t minus kx. Got it? So because this is propagating, let's suppose along x-axis, so we have kept it as it's this part suggests you it's propagating along positive x-axis. Got it? Now, so this is I cap. Let's suppose if I keep it like this, J. So I think if we keep it like this, so shall I put it like this? Then using the same cross product concept, we can define the K component also. Either it is plus, we can define the direction for the B also. Either it is along plus K or minus K. You have to follow this rule. So it is J cross K that defines I. So we know the magnetic field would be along K axis. How you define the magnitude? So we'll keep it B naught sine omega t minus kx, and we have just stated it as along K. How these two are related to each other? So we know E naught by B naught is constant, this ratio, the magnitude of electric field vector and the magnetic field vector, that remains constant, and this constant for a EM wave is equal to speed of light. Got it? So electric field amplitude is given to us. We have to find out the magnitude of this one. So this is 18, and we'll keep C over here, and that gives you this one. So this gives you 6 into 10 raised to power minus 8, and because this is magnetic field, so unit wise it has to be Tesla only. So this is the third option we have. Any doubt from this part? So I have tried to explain you all the fundamentals which are there and which you need to understand, which you need to thoroughly understand about this concept. So we have sufficient information from this area. Any doubt now? Moving to the next. Yes, so this is the third option we have. An electron revolves around a nucleus of hydrogen-like atom. The kinetic energy of the electron in the first excited state is this. So this is hydrogen-like atom. So first thing we need to understand the hydrogen-like atom. So the total energy is minus 13.6 Z square by N square, and this total energy is with negative sign, but corresponding kinetic energy is 13.6 by N square into Z square, because this is hydrogen-like species. Got it or not? When you say the kinetic energy in the first excited state, so for the first excited state, the value of N is 2. So for the first excited state. Got it? Now, kinetic energy is known to us as 13.6 only. N square, 2 square becomes 4, so this goes, and Z square is equal to 4, so Z becomes 2. So we were supposed to find out atomic number Z in this situation, which is clearly 2. So the first option. So you have to memorize these two formulas only to solve these kind of simple numericals you have. Any doubt from this part? Any doubt? Sure? Shall we move then? So this is 2. Photoelectric emission occurs only when the incident light has more than a certain minimum value of what? So this is purely based on the photoelectric effect. So when you allow a photon of incident frequency nu, so this is the incident energy. Got it? But if this frequency, incident frequency or incident energy is smaller than, less than the threshold frequency or the threshold energy, what do you call it as? Work function also. Got it? So for the minimum, if this value is equal to threshold, so that would help you, that would help rather your electron to come out of. But if this energy is greater than threshold frequency or threshold energy, incident frequency is greater than threshold, then ejection or emission will happen, and the rest of the extra energy will be its kinetic energy. Got it? So if this incident energy is smaller than this one, then just excitation, no emission. But if this is the greater than this, so then emission would happen only when incident frequency is greater than threshold or incident energy is greater than threshold energy, or sometimes you call it as by other name called work function, that is the minimum energy required by an electron to come out of atom completely. So this is more than its frequency. Got it? Yes, so this is the one. Moving to the next. In a photocell, magnitude of saturation current depends on the intensity of the incident light. Intensity of the incident light. So what do you mean by intensity? Intensity means number of photons striking per unit area per unit time is called intensity. Got it? If more number of photons strike the surface, definitely more number of photoelectrons will be emitted. So photoelectric current with respect to intensity. So this is directly proportional, because the more number of photons means the more intensity you have, and that would help you to extract or to emit more number of photoelectrons, that would contribute your photoelectric current. But saturation current, so this is the one this is called saturation current. So definitely if more photoelectrons are emitted, the saturation current would be higher. You got it or not? So higher intensity leads to more photoelectrons emitted per second, and that leads to a larger value of saturation current or photoelectric current. So the first option seems to be correct. Second, if the separation of the source of light from the photocell increases, okay, then the magnitude of stopping potential remains same. What do you mean by stopping potential? So, we know h nu is equal to h nu naught plus kinetic energy. So, when you have a cathode and you have anode, so when you allow the photon to strike this, photoelectrons would be emitted and would reach. So, if you have a fast moving electron, then what is the, this is basically with respect to applied potential, then what is the negative potential applied to stop this photoelectric current? This is called stopping potential. And this kinetic energy is charge into stopping potential. Got it? This is fixed. Now, kinetic energy depends purely on the incident frequency or the incident energy, nothing to do with what? Nothing to do with photo or nothing to do with the intensity, photon's intensity. You got it or not? So, your question is, stopping potential is depending on the incident frequency or the incident energy, not on the intensity. So, the question is, if the separation of the source from the light of the photocell increases, we know intensity from a point source or maybe from a source is inversely proportional to 1 by r square, where r is the separation. So, with the increase in r, intensity decreases. Got it? But intensity has no role to play for the stopping potential. So, stopping potential remains same because it depends only on this one. So, both assertion and reason are correct, and reason is the correct explanation for this. But sorry, reason is not the correct explanation. So, that is, then the magnitude of stopping potential remains same. Photocells increases. Okay. Photocell stopping potential is independent of intensity. You got it? So, if the separation of the source from the light increases, then the magnitude of stopping potential remains same. Both assertion and reason are true, but reason is not the correct explanation. Okay. Reason is also correct, but reason is not giving you that correct explanation. That is perfectly fine. So, reason is correct, but it has something to do with the explanation from the photoelectric equation. So, I think this is also clear. Shall we move? Which of the following option is true for Zener diode? Okay. This Zener diode is a specially designed diode. Symbolically, the normal diode, PN junction diode, is like this, but for the Zener diode, this is the symbol. Got it or not? Now, this Zener diode is highly doped PN junction. Now, first of all, Zener diode is highly doped. So, both P type and N type are highly doped. So, this is very important point. This is highly doped. You got it or not? So that you have a very thin depletion layer, very thin depletion layer. Got it or not? Right? Now, when you have a very thin depletion layer, second, it is always operated in reverse bias. So, that is also very standard information. So that it can operate without being damaged. So now, based on this information, it's highly doped, both P and N, very thin depletion layer, and this is reverse bias, so that it can operate in reverse bias, current can flow without being damaged. So it's highly doped, this part is correct, but used in forward bias, this is wrong. Weakly doped, this is wrong. Weakly doped, this is wrong. Highly doped, used in reverse bias, so this is the fourth option we have. Yes, highly doped, used in reverse bias. In study of forward characteristics of p-n junction diode, the p side of diode is connected to the positive and n side is connected to the negative. Yes, so this is true. This is p, this is n. When p is connected to positive, n is connected to negative, this is said to be the forward bias. Now let's draw its characteristics. Now take example of silicon. So you have some junction potential, and this junction potential is something like this. So 0.7 volt. This is precisely very near to 0.7 volt for silicon. It means if your applied voltage is less than 0.7, there is no current. The moment you cross, it grows like this. So this is called knee voltage, threshold voltage, or sometimes also known as cut-in voltage. You got it or not? So initially a negligible current. This is purely because of the leakage effect, so we call it as a leakage current. Flows till the applied voltage crosses a certain value. This is knee voltage, cut-in voltage, threshold voltage. So various names given to this. So it says cut-in voltage, yes. Threshold voltage, yes. Breakdown, no. So both 1 and 2, that is perfectly fine option we have. Yes, both 1 and 2. Moving to next, position of a particle moving along x-axis is given by x equal to 4t plus 5t square, where x is in meters and t is in second. The acceleration of the particle at time 2 seconds will be. Okay, so position is a function of time. So when you differentiate, you will get instantaneous velocity, and that gives you what? 4 plus 10t. But here they are asking about acceleration, so we'll again differentiate the velocity expression, and that gives you the instantaneous acceleration. The constant, the derivative of this constant is 0, so it's 10, and unit wise meter per second square. So this is the fourth option we have. Any doubt from this part? Rishabh has given me the right answer. Good, Rishabh. A body is thrown vertically upward such that the distance traveled by it in the 5th and the 6th seconds are equal. The maximum height reached by the body is. Okay. So you are projecting a body from the ground. So it takes, so distance traveled by the body in the 5th and the 6th second. So this is the 5th second and this is the 6th second. It means distance traveled by the body in the first second of its downward journey is equal to the distance traveled by the body in the last second of its upward journey. So that is 5th second is equal to 6th second. It means body is taking 5 seconds to reach its maximum height. I think this is clear to everyone. So time taken by the body to reach its maximum height, so that is u by g. So this is 5 into 10, so u is 50 meter per second, and for the maximum height we know the formula u square by 2g. So this means 50 into 50 by 2 into 10, and that gives you 125 meter as the maximum height reached. So this is also quite easy and interesting situation. Any doubt from this? Yes, time of flight is 10 seconds. Very good. So time for the upward journey, time for the downward journey, and assuming there is no air friction, so that means it's 10 seconds. Good. Shall we? So this is 125. Now, the tangential component of acceleration of a particle in circular motion. Okay. So you have a circular motion. Got it? Now there are two types of circular motion. You may have a uniform circular motion. So in uniform circular motion, speed of the particle remains same all along the path. It's only the direction that gives you the change in the direction only, that is tangential, and that gives you the concept of velocity. Velocity is varying because of its direction. And you have centripetal acceleration that is directed towards the center. So this is the case of uniform. But in case of non-uniform circular motion, its speed is also varying. It means the body will have one speed at this point, body may have increasing speed or may have decreasing speed. Both the situations are possible. So in non-uniform, you may have increasing speed and you may have decreasing speed. Both the options are there. So because of this, what you have another component. So you have tangential acceleration. Got it? In addition to centripetal acceleration. Centripetal acceleration is also there. So centripetal acceleration gives you the change in the direction, but it gives you the change in the speed, magnitude. So if you have increasing speed, so velocity and tangential acceleration are in the same direction. But if you have a decreasing speed, so in situation of decreasing speed, you may have tangential acceleration opposite to the velocity vector. You got it or not? So both the options are there. So we are talking about the tangential component of the acceleration. So we are talking about this AT. It gives you the change in the direction? No, because this is purely because of centripetal. Change in the magnitude, change in both magnitude and direction, no change in magnitude. So what is the answer? Second option. Yes, change in the magnitude of velocity. Moving to the next, 3 blocks A, B and C of masses 4 kg, 2 kg and 1 kg are respectively are in contact on a frictionless surface as shown. If a force of 14 Newton is applied on the 4 kg block, then the contact force between the blocks A and B is. Okay. So this is A and we have B and C also. So A is 4 kg, this is 2 kg and this is 1 kg. So what is the acceleration? So acceleration is applied force by the total mass of all the bodies combined together. So this is what? A force of 14 Newton and the combined mass of the system is 7. So acceleration is 2 meter per second square. But now we have to find out the contact force between blocks A and B. So this is the contact force. We are supposed to find it out. So let's suppose we combine B and C as one system. So here we are talking about this force. This force is mass of combined system multiplied by the acceleration, mass of B and C. So what is this mass is? B and C 3 and acceleration is 2. So this is 6 Newton. So this is 6 Newton, option number 3. Yes, so this is 6 Newton. Moving to the next question, a girl of mass 40 kg sits in a swing of length 6 meter. If a person pulls the swing to the side, so that swing makes an angle of 60 degree with the vertical, the gain in potential energy is. So you have a swing, so this is like a pendulum. So when you take it to a side and it makes an angle of 60 degree, so you have already attained a height with respect to this ground reference. Got it? If L is the length, now at this point potential energy is given by mgl 1 minus cos theta. So this is the gain in the potential energy of the girl. So this is, we are considering it as a sort of pendulum, and it is taken to a height and inclined at an angle of 60 degree. So what is this mass is? 40. We'll keep G. G is not, so this is, we'll keep it as 9.8. Length is what? 6 meter. 1 minus cos 60 is 1 by 2. So that precisely keeps it as 2. And when you multiply it, it's close to 1176 joules. Got it? Any doubt? So this is the option. Now the next question says two rotating bodies A and B, moments of inertia IA, IB, where IB is greater than IA, have equal kinetic energy of rotation. If LA and LB be their angular momenta respectively, then, okay. So I am talking about the rotational kinetic energy. Got it? Now take an analogy with the translation motion. So in translation motion, so kinetic energy is p square by 2m, and linear momentum can be written as 2m into kinetic energy under the root. Now use the same expression for this analogy of this for the angular rotational concept. So p is replaced with L, 2m is replaced with I, and E is kinetic energy. Let it be E only, rotational kinetic energy, and this is the 1. Now we have to compare their angular momenta only. So two rotating bodies of moment of inertia have equal kinetic energy. So kinetic energy is same. So for LA and LB, so this is IA and IB under the root. IB is more. So when IB is more, definitely LB will also be more than LA. So this is the option, second option. Yes, so this is the second option. Any doubt from this part? Good. Moving to next. A geostationary satellite is orbiting the Earth at a height of 5r from the surface of Earth. Okay. So this is the Earth having radius. So at this point, this height is what? 5r. A geostationary satellite, so its time period is 24 hours. We have to find out the time period of another satellite in hours at a height of 2r. So at a height of 2r, so this is what you are supposed to find it out. Now this is a simple question from your Kepler's law, and law of period says t square is directly proportional to r cube, where this is the orbital radius. So for first body, t1 square is equal to, so now look at this, the small r looks like 5r plus r, 6r, and for the second body it's what? 2r. We'll simply take the ratio. So this becomes 2 power 3. Now T1 by T2 is 2 power 3 by 2. So that we can write it down as 2 root 2. Now T1 is given to us as 24 hours and we are supposed to find out T2. So this is 12 and this is 6 into 2, so 6 root 2. So T2 becomes 6 root 2 hours. So this is in hours, fourth option. Any doubt from this part? Shall we move? Yes, so this is 6 root 2. Moving to the next. The increase in pressure required to decrease 200 liter volume of liquid by 0.04% in Pascal, and bulk modulus of the liquid is known to us as 2100 kilopascal. Fine. So this is a very simple numerical. We know the formula for the bulk modulus is minus delta P delta V by V. So we have to find out increase in pressure. This negative sign indicates only because of the increase in pressure only there is a decrease in the volume, and bulk modulus is 2100 kilo 10 to the power 3 Pascal, and volume 0.004%. You got it or not? And when you solve it, it gives you a simple 84 as the answer, because all the 10 powers cancels out each other. This volume has no significance because when percentage decrease or percentage change in volume is known to us, so then the initial volume will make no significance for this numerical data. So this is 84. Yes, this is 84. Now moving to the next question. When an ideal gas expands adiabatically, its temperature. Okay. So the process is adiabatic. So first we'll keep the basic energy conservation rule, that is your first law, that says delta Q is equal to delta U plus P delta V. Because this is adiabatic process, so delta Q is 0. There is no heat exchange between system and surrounding. So we'll keep delta Q as 0. It means delta U is equal to negative of P delta V. So this is from where we have to pick the question now. Now the gas expands. So when you have expansion stroke, so this P delta V would be positive for the expansion part. So ultimately delta U becomes negative. The change in internal energy is negative, and internal energy is a function of temperature. So if internal energy decreases, temperature also decreases. So it means when a gas expands adiabatically, its temperature decreases. It means it cools off. So this is second option, it decreases. So any doubt from this part? Let's verify it. Yes, it decreases. Any doubt? Very good. So nice comment. Good. Thank you. So now we'll take a short break and we'll resume, and the next questions from 24 onwards to 45 will be taken care by Kumaran sir. So he'll help you to understand the rest of the questions, and we'll take a short break. Thank you very much. Thank you.
Hello everyone, I hope everyone is having a great time on the other side, right? So Puneet sir, he covered questions from 1 to 23, right? Okay. Many students have already joined in. Okay. So I am Sri Kumaran, your physics faculty at Aakash, and now I am going to continue with question number 24 onwards, alright? And the paper as a whole, it was pretty light, wasn't it? Some good questions along the way, right? We will look at them as well. ठीक है, कुछ छोटे छोटे concepts पर we will also have some nice discussion और कुछ एक दो question मैं आपसे I will pose them along the way as well. ठीक है, तो चलिए, तो let's begin with where he left off, that is question number 24. So read the question, what it says. थोड़ा सा concept also we would be discussing. So which of the following equation does not represent a simple harmonic motion? है ना? Lots of students have doubts in such a simple question, right? So let's read the options. First one, y is equal to a sin omega t, then y is equal to a cos omega t. So both options are similar. And the third, as you can see, a sin omega t plus b cos omega t, and the fourth one being 2a sin omega t plus a cos 2 omega t. Okay, so first up, what is simple harmonic motion, right? So simple harmonic motion, right? Something to remember, as in if you see each of these options, right? It's given y is equal to something, right? As a function of time. So y is your displacement, t is the other variable time. Okay. So if y is given to you as some function of time, okay, then you would find dy by dt, that would give you your velocity of that particle as a function of time once again, right? Let's say I am calling it as v, and then you will find d square y by dt square. Double derivative of y, which gives you your acceleration, right? Also as a function of time, right? You find them up, and then please note down, then you have to check this important relation for SHM. That is, this acceleration A has to be proportional to minus x, right? Or rather, where x is your displacement. Since here the displacement is along y, so instead of x we can talk about y, right? So acceleration has to be proportional to minus y. That's all. So if this condition is being satisfied, then we will say that yes sir, it is a SHM, right? So first up is y is equal to a sin omega t, right? You guys can check it on your own also, but let me show you also. So first option, right? A sin omega t. So let's write this one here. Differentiate it. How do we differentiate? Remember, A is a constant, the amplitude, so it remains outside. So we are going to differentiate sine. Okay, so we are going to apply chain rule. So differentiation of sine, okay, differentiation of sine will become cos. So sine theta will become cos bracket. Okay, so sine bracket will become cos bracket, and then you differentiate bracket with respect to time. Bracket is your omega t. So omega t with respect to time will become omega only. Okay, so here we will write omega. That omega, if you want, you can write it in the front itself. That is, it will become a omega. All right, a omega. Bracket is what? Cos omega t. All right. Okay. Then differentiate this one again with respect to time. Once again, see a omega is coming in the amplitude section. So it's like a constant. Treat it as a constant. So a omega is a omega only. You're going to differentiate cos. Differentiation of cos bracket is going to be minus sine bracket. Okay. So minus sine bracket, then differentiate the bracket with respect to time. Again you are going to get again another omega. So that omega coupled with this a omega gives you a omega square. Okay? A omega square. Alright. But also note, here in the amplitude we have a, right? And so in that case, here we won't write this a as acceleration, right? So let's change the variable for acceleration in such a case. So let's say I am calling the acceleration as capital A. Okay, which means here also I will change it in order to remove any confusion on your side. All right. So now you can see this capital A is like this. Now compare it with the original. What was the original? Y is equal to A sin omega t, right? So you can pluck A sin omega t from here. है A and sin omega t. Keep it on one side. What is left? Minus n omega square are left. ठीक है, तो इसको हम क्या लिख सकते हैं? As a whole, we can write minus omega square into y. Okay, that is this acceleration A is equal to minus omega square into y, which means it has satisfied this condition, right? Satisfied this condition meaning it is an SHM. Okay, so therefore this is an SHM. This is an SHM. Similarly, this one also you can check, it is also an SHM, right? Follow the same steps, cos here, so here it will become minus sign, then here again it will become minus cos, right? So once again you will have this expression, huh? So it is an SHM. What about this one? This is also an SHM, right? Because here if you see A sin omega t and B cos omega t as a whole, if you take them, right, and if you apply the same thing, then also you will get. If you want, we can check also, huh? So shall we check it over here? No issue. Let's check this option, huh? So y is given to you. Let's find dy by dt. If you differentiate, it will become a omega cos omega t plus, see now I am directly writing because we know the formula, then this will become b omega sin omega t but with a minus sign because cos differentiation is minus sign, huh? So b omega sin omega t with a minus sign, so this will become minus b omega sin omega t. Okay, then again you differentiate. If you differentiate it again, d square y by dt square, that is acceleration. This differentiation will become minus a omega square sin omega t, and this one minus b omega square cos omega t. Okay, once again from here take minus omega square common. Okay, so please note down what this becomes. This I can write it as acceleration, that is a. Okay, minus omega square taken as common. So what is present inside the bracket? देखिए ध्यान से, that is a sin omega t plus b cos omega t, right? And this, my dear friends, is your original y. So I can conclude that acceleration is equal to minus omega square y. Pretty much the same expression that we got over here, right? The same expression we have got over here also. That is, once again, this is also an SHM. Okay, and what about the time period of this SHM? है ना, time period देखिए, notice on the angular frequency. ठीक है, angular frequency क्या है यहाँ पर? It is omega here. Here also it is omega, and for this one also angular frequency is omega. है ना? So for all these three, time period is going to be simply 2 pi by omega of this SHM. ठीक है. Now what about the fourth one? What about the fourth one? So fourth one is not an SHM. ठीक है ना? Fourth one is not an SHM. Why so? Again, if you want, you can check using the same method. You can check using the same method, and you would see that it won't come. है ना? This condition won't be coming for this fourth option, if you want. Right? A nice way to remember is, see here that first term if you see, what is the angular frequency? Omega, right? And the second term, the angular frequency is 2 omega, right? Angular frequency is 2 omega. So it's like, what are we doing, right? So what are we doing? It's, this third equation is like a superposition of two separate SHM with different angular frequencies, है ना? So their result is not going to be an SHM. आप ऐसे भी याद रख सकते हैं, but if you want, we can use the simpler method, that is simple derivation and we can find out also. Okay? So fourth one is going to be our answer. All right. I would always suggest you guys can see how many steps it's going to take. Hardly those steps. That's all. Hardly those steps. One differentiation, second derivation. That's all. You would be easily be able to check whether it's an SHM or not. All right. So this does not satisfy, and fourth one is our answer. Let's check the answer slide. And yeah, fourth one is our answer. Okay. Yeah. Some students have already replied. Yes, option 4 because there is 2 omega t. Yeah, exactly. Just by looking at the option itself, you could have ticked the answer. But still, we derived it and I explained it for the first 3 options also. Anyway, so moving on to question number 25. See this question? It's based on your meter bridge, right? So in a meter bridge, 2 ohm resistance is connected in left gap and the balancing length from left end is found to be 20 centimeters. Okay? The value of unknown resistance is, right, the value of unknown resistance which you would connect in the right gap, right? 2 ohm resistance is connected in the left gap. So how to find the unknown resistance? So you result and you can remember the result also, or you can remember the diagram also, right? So if I were to draw a simple diagram, right, so it's like this, you have A and B, right, and here let's say is your galvanometer, right. Using the galvanometer we are checking where the balance point is being obtained, and this let's say is the first resistance connected over here and this is the second resistance connected over here, right. 2 ohm is connected in the left gap. So this is 2 ohm and this is the unknown resistance, let's call it X, right. A simple schematic diagram that I have drawn for you guys, and obviously you have the battery, right, that is the potential difference that is let's say supplied over here. Okay, a very, very simple diagram, and this remember is your balancing length, right. So balancing length L1 over here, or you can call it L also, then this will become 100 minus L, right, because the total length AB is 1 meter because it's a meter bridge. All right, 1 meter, or let's say I'm calling it 100 centimeters. Okay. Now what about the balance point? The balance point is obtained over here, which means over here the deflection in galvanometer is 0, right. So there is no current passing through the galvanometer. When that happens, what do we say? That R1 by R2, right. R1 by R2, that is on the left side of galvanometer, right. Focus on these 2 sections. 2 ohm by, let's call this point as something as well, AC, right. So 2 ohm by resistance of AC. 2 ohm by resistance of AC is going to be equal to, on the right side, X over resistance of BC. Okay. If you want, you could have directly written it like this also. That is 2 by X is equal to resistance of AC by resistance of BC, because this remember is your simple wire, right, from A to B. And remember, for AC and BC, the area of cross section is same. The area of cross section is same, but what is different? The length of the wire is different. What else is same? The resistivity is same. And we know that resistance of a wire is given to you by the simple formula R is equal to rho L by A, right? Resistivity times the length upon area of cross section. So for AC and BC, rho is same and A is same. So when you take their ratio, ratio लेने पर फिर क्या रह जाएगा? Rho और A तो कट गए, right? So what remains is your L only. So ratio of resistance is nothing but ratio of length. और length ratio क्या है? ये length L1 by ये total length क्या है 100, तो ये कितना हो जाएगा आपका? ये वाला length कितना हो जाएगा? 100 minus L. So इसको मैं लिख सकता हूँ L1 by 100 minus L1. Okay, that's it. So this result we are going to be using. That's all. चलिए, everything else is given, right? X आपका unknown resistance है. That's it. Use that formula. देखिए मैं formula direct यहीं पे लगा दे रहा हूँ. 2 by unknown resistance x is equal to balance point length is how much from the left side? 20 centimeter. So 20 centimeter divided by 100 minus 20, right? 100 minus L, right? This will become 100 minus 20, 80 centimeter. Okay? So centimeter by centimeter it will cancel out. That's it for this question. इतना ही करना था आपको. तो इसको solve करिए. This if you see cancels out, right? 1 and 4. Therefore x is gonna become 4 into 2. 4 into 2, right? That is x is equal to 8 ohm. ठीक है? Pretty straightforward question. This one was. है कि नहीं? All right. चलिए अगले में चले. Let's check the answer as well. है ना? देखिए 8 ohm is your answer. है ना? If you know the method, directly आप कर सकते थे. Direct formula भी आप लगा सकते थे. Okay. Moving to question number 26 now. ये देखिए. It says a narrow slit. है ना? A narrow slit यानी कि एक स्लिट की बात कर रहे हैं. एक स्लिट यानी कि डिफ्रैक्शन की बात कर रहे हैं. ठीक है? A narrow slit with 2 millimeter is illuminated by monochromatic light of wavelength 500 nanometer. Okay? The distance between the first minima on either side on a screen at a distance of 1 meter is. ठीक है? तो स्क्रीन का डिस्टेंस आपको दे दिया गया है, that is capital D आपको दे दिया गया है, right? The width of the slit वो भी आपको दे दिया गया है, right? Width of the slit we denote it by small d, right? Monochromatic light meaning that the only one particular wavelength is used for that light, है ना? ऐसा नहीं कि we are using red light, violet light, blue light like that. No, no, no. Only one wavelength you are using. Wavelength is also given to you, 500 nanometers. ठीक है? So wavelength is given to you, that is lambda is given to you. Right? Distance between the first minima on either side on a screen. ठीक है? तो let's draw a rough diagram. Once again, a small rough diagram. ठीक है? बहुत ज़्यादा नहीं बताऊंगा diagram में. देखिए. Let's say this is your screen over here. ठीक है? And here is your slit like this, like this. ठीक है? If we want, we can draw the slit little smaller also. It doesn't matter. Right? Either way, the slit width is smaller. Okay? Anyway, so this remember is your slit width, D that I am talking about. Right? And then, just a minute. Yeah, and then you have the distance of the screen, right? Distance of the screen from the slit, that is capital D, that's also given to you. The wavelength lambda is also given to you. The distance between the first minima on either side on either side on a screen. On either side meaning either side किस चीज़ का either side? किस चीज़ का मतलब उन first minima के बीच में क्या है आपका? Right? So remember here at the center you have your central maxima. ठीक है? At the center you have your central maxima और central maxima के इस तरफ और उस तरफ you have your first minima. ठीक है? और first minima के लिए first minima के लिए remember and compare the formulas of YDSC with diffraction. ठीक है? YDSC में first maxima is let's say obtained at other than central maxima I'm talking about. हाँ? So the first maxima is obtained at n equal to 1. ठीक है ना? और उसमें हम क्या कहते हैं delta x यानी कि जो part difference है the delta x is equal to n lambda. ठीक है? In diffraction it's the reverse. First minima is obtained at delta x is equal to n lambda. ठीक है? तो n is equal to 1, we call it like that. Huh? So delta x is equal to n lambda और n इज इक्वल टू 1 ओवर हियर, ठीक है. एंड दैट डेल्टा x इन वाईडीएसी एंड डिफ्रैक्शन वी राइट डेल्टा x इज इक्वल टू d sin थीटा, ठीक है ना. समटाइम्स इन बुक में this d is taken as a also, small a. So in that case delta x will be taken as a sin theta, okay, a sin theta. Then remember this screen distance capital D is much larger than this small d, ठीक है. So that means that sin theta will be same as your tan theta, ठीक है ना. So let's say over here, so we have to draw a rough diagram once again, ठीक है ना. तो ये आपका ये y है, ओके, दिस इज योर थीटा, है ना. सो डेल्टा x क्या है, a sin थीटा और d sin थीटा, है ना. आई एम राइटिंग इट d sin थीटा, बट sin थीटा कैन बी अप्रोक्सीमेटेड इट एज tan थीटा, approximately tan theta, and tan theta can be written as what? From this right angle triangle, if you see, right, this is your perpendicular and this is the base, right. So base length is how much? Capital D, है ना. So tan theta क्या हो जाएगा? Y upon capital D. So this will become D into tan theta, that is D into Y upon capital D, that is equal to lambda, ठीक है. तो Y आपका क्या आ गया? From here Y is coming lambda D by small d, ठीक है. लैम्डा डी बाई स्मॉल डी, तो ये क्या है आपका पोजीशन ऑफ फर्स्ट मिनिमा, है ना. सो दिस इज द पोजीशन ऑफ फर्स्ट मिनिमा, राइट. बट अब क्वेश्चन पढ़िए फिर से. दे आर सेइंग द डिस्टेंस बिटवीन फर्स्ट मिनिमा ऑन आइदर साइड, यानी कि हियर लेट्स से एट द सेंटर यू हैव सेंट्रल मैक्सिमा, यहाँ पर फर्स्ट मिनिमा, विच मीन्स ओवर हियर ऑल्सो देर इज गोइंग टू बी फर्स्ट मिनिमा वंस अगेन, ठीक है. तो यहाँ पे भी, तो यहाँ पे भी होगा. दिस ऑल्सो वाई, देन दिस डिस्टेंस विल ऑल्सो बी वाई. तो यानी कि द सेपरेशन विल बिकम हाउ मच, है ना. द सेपरेशन विल बिकम हाउ मच. तो ये भी मैं इसको वाई ड्रॉ कर देता हूँ. द सेपरेशन विल बिकम 2y, ठीक है. सो द सेपरेशन इज बिकम 2y, दैट इज 2 lambda d by small d is our answer, okay. And that separation is given, or rather we have to find it, that separation, let's find it over here and use that formula, 2 lambda d by small d, that's it. Just substitute the values and you will get the answer, 2 तो 2 है, lambda is how much? 500 minus 9. कैपिटल D क्या है? कैपिटल D इज योर 1 मीटर, राइटिंग इट इन ऐसा यूनिट तो 1 ही है. स्मॉल d, राइट, स्मॉल d इज योर स्लिट विथ, राइट. स्लिट विथ क्या है? 2 मिलीमीटर. सो 2 मिलीमीटर, दैट इज 10 की पावर माइनस 3, राइट. अब इसको सॉल्व करिए. 2 and 2 will get cancelled, है ना. 10 पावर 3 ऊपर जाएगा ये, this will become 10 power 5. 10 power 5 multiplied by 10 power minus 9. This will become 10 power minus 4. तो ये क्या हो जाएगा? 5 into 10 power minus 4 meters. But if you see the options, it's all written in millimeters, है ना. तो यानी कि answer is not yet reached. You have to go further. तो इसको मिलीमीटर में कन्वर्ट करिए. 1 मिलीमीटर कितना होता है? 10 power minus 3 meters. तो 10 power minus 3 को leave it here and take the rest with 5, ठीक है. बाकी को 5 से जोड़ दो. So this will become 5 into 10 power minus 1 into 10 power minus 3, है ना. तो ये क्या हो जाएगा? 0.5, ठीक है. 0.5 into 10 power minus 3 meters, that is 0.5 millimeters, okay. Leaving us with option number 2 over here, right. Pretty simple. This question was once again direct formula oriented question, है ना. फॉर्मूला पता है, आपने तुरंत कर दिया उसको, ठीक है. ऐसे आपको बहुत सारे सवाल पूछ सकते हैं यहाँ पर, है ना. जैसे मान लो वी हैव आस्क्ड डिस्टेंस बिटवीन फर्स्ट मिनिमा ऑन आइदर साइड, मैं यहाँ पे पूछ लूँ डिस्टेंस बिटवीन जो पहला सेकेंडरी मिनिमा है ऑन आइदर साइड, उसके बीच में पूछ सकते हैं, या फिर सेपरेशन बिटवीन सेकेंडरी मिनिमा ऑन आइदर साइड, है ना. डिफ्रैक्शन में हम ऐसे ही बोलते हैं. एंड इफ यू सी डिफ्रैक्शन में वो इंटेंसिटी का जो ग्राफ है दैट ऑल्सो यू नीड टू रिमेंबर, है ना. हाउ इज दैट ग्राफ लाइक इन YDSE? द ग्राफ इज लाइक दिस, right? That intensity graph has the intensity having maximum intensity at central maxima and at every consecutive maxima. और जो intensity की value है, right? That maximum intensity value is also same at each maxima, but not over here. यहाँ पर नहीं, है ना. यहाँ पर देखिए at maxima, that is central maxima, you have the maximum value of intensity. उसके बाद it drops on and on, है ना. It's like this, huh? It's going to drop. So as you go further and further away from the center, intensity going to drop further and further. ठीक है. So we could have asked the separation between, ऐसे भी है ना, separation between secondary maxima on either side. ठीक है. तब कैसे करेंगे फिर? देखिए उसके लिए फिर मैक्सिमा वाला फॉर्मूला लगाना पड़ेगा. That's it. और rather अगर यहाँ पे पूछते डिस्टेंस बिटवीन सेकेंड मिनिमा ऑन आइदर साइड, वो तो तुरंत लग जाएगा आपका, है ना. सेकेंड मिनिमा यानी कि n क्या हो जाएगा 2. ठीक है. दैट्स इट. और ये ध्यान रखना, इससे जो y निकाल रहे हो दैट इज ओनली ऑन वन साइड, तो पूरा सेपरेशन निकालने के लिए यू हैव टू डबल इट. हाँ, सो y विल बिकम 2y. ऑलराइट, सो आई होप यू गाइस गॉट दिस क्वेश्चन. सो 0.5 millimeter इज आवर आंसर, राइट. लेट्स मूव टू क्वेश्चन नंबर 27 नाउ. ठीक है. ये देखिए क्वेश्चन 27 देखिए. A simple question based on your fluid chapter, है ना, based on your hydraulic lift topic. देखिए क्या कह रही है. hydraulic lift used as a car service station. हाँ, the radius of the large and small piston are in the ratio 10:1. यानी कि उसका जो एरिया का रेशियो है that we can find out, right, because their radius ratio is given to you. Okay, what weight placed on small piston will be sufficient to lift a car of mass 1000 kg. ठीक है. So we are placing a small weight on small piston and on the large piston we are supposed to be lifting a car. ठीक है. So if I were to draw a rough diagram once again, right, this is let's say your large piston. हाँ, थोड़ा सा बड़ा बना दिया मैंने. हाँ, और यहाँ पर आपका क्या है, कार. ओके, कार लेट्स से लाइक दिस. आई होप इससे आप समझ रहे हो. एंड यहाँ पर हमने एक छोटा सा वेट रख दिया. ठीक है. एंड ऑब्वियसली व्हाट इज द एरियाज? इसका एरिया है A1, इसका एरिया है A2. ठीक है. और ये जो फोर्स एक्सर्ट कर रहा होगा, द फोर्स दैट दिस वेट इज एक्सर्टिंग ऑन दैट पिस्टन, राइट. सो लेट्स कॉल दैट फोर्स एज F1. What about the car? Car is let's say exerting force F2. ठीक है. I'm writing it over here. And this remember is your hydraulic lift. ठीक है ना. That means this is connected to that. All right. So let's say something like this. है ना. Something like this. ठीक है. And here obviously fluid is filled. ठीक है. तो इससे when you are placing small weight on the small area, you can lift heavy weights on that large area. ऐसे. Alright, तो हमका क्या है, simple, you are going to be using Pascal's law, that is pressure over here is equal to pressure over there. That's all. So pressure over here is how much? F1 by A1, right? Force per unit area is pressure. And remember this force is acting perpendicular to that area. ठीक है. तो F1 by A1 is equal to F2 by A2. That's all you have to do in this question. ठीक है. Pascal's law. ओके. ब्रिंग फोर्सेस टू वन साइड. तो मैं क्या लिख सकता हूं, देखो, F1 by F2. Alright. If you want, instead of writing F1 or F2, I can also write smaller and larger. ठीक है. that one was smaller, wasn't it? So let's light that instead. Area also, है ना? Area, let's say I'm writing it in capital. Once again the same thing, smaller and larger. और यहाँ पर my dear friends, what is the area of that piston? ध्यान रखिए, area of that piston is in circular shape, which means that area of cross section will become pi r square, right? Radius of large and small piston are given to you as their ratio form, है ना? तो area क्या लिखेंगे? pi r square simple, pi r square, यहाँ पे भी pi r square, तो दोनों का क्या हो गया? रेशियो हो गया, है ना? This is radius of that smaller piston, this is radius of that larger piston, है ना? Right? Now if you see, pi and pi will get cancelled. This ratio is given to you already, है ना? Ratio, remember, is given as the radius ratio of the radius of large piston to small piston, है ना? तो ये क्या हो जाएगा फिर? Small to large, 1/10. Large to 1 is 10:1. This will become 1/10, right? 1:10. So 1/10 whole square. 1/10 whole square will become 1/100, है ना? And if you see over here, they are asking what weight should be placed on small piston, and remember that weight has been given in kg obviously, right? So let's say that weight is equal to m, ठीक है? Here let's say that weight or the mass is equal to m, which means weight क्या हो जाएगा? m into g. m into g, that is this F1 will be equal to m into g. Similarly, let's say mass of the car is given to you as capital M, है ना? तो F2 क्या हो जाएगा फिर? Capital M into g, ठीक है? So if you come over here, so for that small piston, let's say the mass is m, ठीक है? तो ये क्या हो जाएगा? m into g, और इसका भी मास गिवन है, कार का भी मास 1000 kg, तो वो भी हो जाएगा m into g. So let's write that m into g upon 1000 into g is equal to 1/10 whole square, that is 1/100. Okay, so that's it, we got the answer. एक आंसर देखिए क्या हो जाएगा. So if you solve for it, g and g will get cancelled. 1000 goes over there. 1000/100 will become 10. So m is equal to 10. ठीक है? It is 10 kg. All right. So 10 kg is going to be our answer. ठीक है? Let's check with the answer slide. And yeah, 10 kg is our answer. चलिए. So this was a pretty easy question. ठीक है? Moving on to question number 28. 28 भी थोड़ा सा डायरेक्ट है, थोड़ा सा I guess formulas if you remember you can do it directly, है ना? थोड़ा सा हम derive भी करेंगे, don't worry. So escape speed from the earth's surface, this you have to note it down, ठीक है? From the earth's surface is VE. The escape speed from the surface of a planet whose radius is half and mean density is double that of the earth, ठीक है? So first let's come back to the official or the original formula of escape speed, है ना? Escape speed का formula क्या होता है? Let's say you are throwing that ball from a height h, and we are talking about earth only right now, ठीक है? Earth का mass let's say capital M. So you are throwing that ball from a height h above the earth surface. तो escape speed क्या होगा उस केस में? √2g, g क्या है आपका? ग्रेविटेशनल कांस्टेंट, है ना? m is your mass of earth, me upon height h above earth surface, है ना? तो ये क्या हम लिखेंगे? स्मॉल r rather, हाँ, स्मॉल r. स्मॉल r is the distance of that point from the center of earth, ठीक है? लेकिन when I am saying radius of earth is capital R, height is small h, तब ये क्या बन जाएगा? 2g me by r plus h. ठीक है, where r is what? Radius of earth. Okay, but if you come to this question once again, they have said escape speed from the earth's surface only. From the earth's surface. तो यानी कि h क्या है आपका? 0. h is 0. So therefore this will become simply under root 2g me by re only. Okay. h is 0, huh? h is 0. So this will become under root 2g me by re. Okay. So from the surface of any planet, you can remember the formula as under root 2g mass of that planet by radius of that planet. Now if you come back to this question once again, right, what are they saying? They are talking about the radius and mean density of the planet, है ना? So how do you express mass of that planet, let's say earth, in terms of radius? वो कैसे लिखेंगे? देखिए, you will write mass of earth as density times the volume of earth. Density is, let's say, rho times the volume. Volume is what? 4 by 3 pi r cube, है ना? ये क्या है? ये radius of earth है. Okay, right? So what will become me by r? What will me by r become? देखिए ध्यान से. So me by re, that is nothing but divide both sides by re. So this is going to become rho times 4 pi by 3 into re square, right? And this you take it from here and substitute it over there. तब क्या हो जाएगा? See, this term is a constant, right? Or rather, rho we are changing, right? So rho we cannot say is a constant, or rather I can say this 4 pi by 3 is a constant. ठीक है? And over here if you see, this 2 and g are constants, है ना? So when you substitute it over here, what will this become? If you want, I will write the full expression. Okay, so no problem in writing the full expression. 2g, 2g rho 4 pi by 3, that is 4 pi rho by 3 into re square. ठीक है, अब यहाँ पर देखिए, who are the constants? This 2g 4 pi by 3, they are all constants, है ना? So I am saying they are constants. So instead of making such huge derivation, you could have directly done also, हाँ? कि mass जो है देखिए कैसा vary कर रहा है, mass is proportional to rho into re cube, then mass by radius will be proportional to rho into re square. सिर्फ उसको उठा के you substitute it over here under the root. If you substitute it under the root, remember 2 and g are also constants. So you will be able to write this v escape speed proportional to, neglecting the constants, because remember we are writing in terms of proportional to. Tab what are the variables? Only rho and re square. So this I will write, it is proportional to under the root rho into re square. If you want, you could have directly done also. So I have shown you step by step how to do it. Okay, and this if you want, you can simplify it further. That is under root re square will become under root re only, right? So this can also be written as under root rho into re. Okay, or if you want, you can remember it by this also. Anyway, so we're going to be using this expression. That's all. Okay. So if you see over here and come back to the question for Earth and for that planet, so let's take the ratio of their escape speeds. Okay, so let me write it down over here. So for escape speed for Earth, I am writing it as V Earth. So V Earth by V planet is equal to under root rho into re square, isn't it? Yeah. So here you can write under the root, है ना, rho of earth by rho of planet okay, and then r of earth upon r of planet, obviously whole square. All right, and that's it. Just solve for it. So saying planet has radius half, so this radius of planet is going to be re by 2. Okay, so re by 2, and what about density of planet? That is double that of earth. And so density of planet is 2 rho e. So when you write 2 rho e over here, rho e will get cancelled. So what remains? And okay, so one more thing students can ask, sir, there we had written V earth proportional to, hai na? But here how did the equality sign come? So remember students, when you write such proportional to, right, so V proportional to something, so you can take the ratio, that is V1 by V2. Huh? So V1 by V2, when you take that ratio, here on the RHS side, what will remain? This term only. So this term's ratio you have to take it on the RHS side, because those constants, whatever they were, that is these constants, hai na, they will come in the numerator also and denominator also, and they will get cancelled out. तो cancel हो जा रहे हैं, इसलिए हम नहीं लिख रहे हैं उनको. ठीक है, चलिए वापस आते हैं. So let's come back. So density of planet is double, so 2 rho e, so this will become 1 by 2, and radius of planet is half, so this will become 2 times, right? So 2 square, that is 4 by 2 is 2, under root 2, right? So under root 2. So therefore, what is velocity of planet? Velocity of planet is equal to this velocity of earth divided by root 2, hai na? See, this will go over there, root 2 will come over here on the LHS, hai na? So this is going to be our answer. And escape speed from earth surface is V, so the answer is going to be V by root 2, that is option 3 over here. Okay, I hope you guys have got it, right? And yeah, option 3 is our answer. Okay, so let's move to the next question, right? Question number 29, है ना? ये भी एक छोटा सा सवाल है, much more simpler. Let's read on. What it says, कि when a spring is stretched by 1 centimeter, है ना? So 1 centimeter as in, let's say 1 centimeter from natural length, है ना? So that is, let's say it has been stretched by x. It stores energy 50 joule. If it is further stretched by 1 centimeter, the stored energy will be, ठीक है? The stored energy will be. क्या आप लोग try कर सकते हैं? Can you guys try it and tell me what the answer will be? बहुत simple सवाल है ये भी, right? देखिए try करिए. Yeah, so someone is saying option 4 is the answer. Okay, fair enough. Let's see. देखिए, when it is stretched by x or when it is compressed by x from natural position, है ना? So जो stored energy होगी, वो क्या होगा? When elongated or compressed by x from natural length, ठीक है, the stored energy in the spring can be written as what? Half k x square. ठीक है, याद रहेगा ये half k x square. So this is the formula we are going to use. So if you see in the first case, है ना, in the first case stored energy क्या है, let's call it U1 is equal to half K, X तो पता है हमको, है ना, this is the X, है ना, this is the X. So half K, X is what? You have to convert it into meter, है ना, but for now I am leaving it in centimeter only, ठीक है, or if you want I can write it over here in centimeter, हाँ. So half K X square. ऐसा क्यों? Because now कुछ देर में हम we are going to be taking the ratio. तो जब ratio लेंगे लेफ्ट साइड और लेफ्ट साइड में, राइट साइड में, सो ये भी सेंटीमीटर में लिख रहे हैं हम, नीचे भी एक और एक्सप्रेशन वी आर गोइंग टू राइट, दैट्स आल्सो ओवर देयर आई एम गोइंग टू राइट इट, दिस टर्म इज आल्सो इन सेंटीमीटर, है ना, तो रेशियो लेने में इट वुड बी इजियर फॉर अस, दैट्स व्हाई. ओके, एनीवे, सो इन द सेकंड केस इफ यू सी, let's call it U1 or if you want you can call it UI also, huh? So U2, that is finally the stored energy will become half K. अब देखो क्या हो गया, टोटल कंप्रेशन और rather टोटल elongation, है ना, पहले स्ट्रेच किया 1 सेंटीमीटर, देन अगेन यू हैव स्ट्रेच्ड इट फर्दर बाय 1 सेंटीमीटर, दैट इज नाउ द टोटल elongation 1 सेंटीमीटर देन 1 सेंटीमीटर, है ना, so total elongation is how much? 2 centimeter. So here you will write 2 centimeter whole square. Okay, that's it. All you got to do is take the ratio. ठीक है, so let's take the ratio U2 by U1 because we are supposed to find U2 only, है ना. U2 by U1 when you take the ratio, this K by 2 constant है ये, constant for that spring, है ना, so it will get cancelled. It's a property of the material of the spring, so it will get cancelled और क्या remains then? 2 centimeter और ये 2 centimeter square 1 centimeter square, है ना, and if you see this centimeter square that will also get cancelled, ठीक है. Now what will remain is 2 square by 1 square, that is 2 square, that is 4 by 1, that is 4 only. So this is equal to 4, है ना, therefore U2 is equal to 4 times of U1. And what is U1, my dear friends? U1 is given 50 joule, 50 joule, therefore 4 into 50, 200, that's it, 200 joule, right? Pretty easy this one was, once again, है ना. So please remember, right, whether you are elongating the spring by X or compressing the spring by X, ठीक है, the total stored energy in the spring is equal to half K X square provided you are stretching or elongating it from the natural length position, ठीक है, natural length position से ही. अगर natural length position नहीं रहा then उस position से if you are stretching or elongating तो expression is going to be different, ठीक है ना, but from the natural length position यही होगा expression. Why? Because natural length position में stored energy क्या है आपका, at natural length there is no elongation, there is no compression, है ना, तो at natural length we say stored energy is equal to 0, right? So that is why with respect to natural length अगर हम देखें तो stored energy is going to be positive and obviously जो stored energy है positive ही होगा वो, है ना, negative तो नहीं हो सकता. Okay, fair enough. Let's move on to the next question. बहुत छोटा सा सवाल था ये, हाँ, चलिए, and obviously yeah, the answer slide says the same, 200 joule. चलिए, तो क्वेश्चन नंबर 30 पे चलते हैं. अच्छा, क्वेश्चन नंबर 30 देखिए, ये भी एक छोटा सा सवाल है फ्रॉम योर एटम्स चैप्टर, है ना. ये देखिए, ये क्या है, ये हाइड्रोजन लाइक, है ना, हाइड्रोजन लाइक का ये बिल्कुल है कि नहीं. वाई हाइड्रोजन लाइक आई एम सेइंग बिकॉज हाइड्रोजन में हाउ मेनी इलेक्ट्रॉन्स आर देयर, 1 इलेक्ट्रॉन, है ना. लिथियम +2 आयन में भी 1 इलेक्ट्रॉन ओनली, है कि नहीं. वाई? बिकॉज रिमेंबर लिथियम हैज एटॉमिक नंबर 3, टोटल नंबर ऑफ इलेक्ट्रॉन्स 3, बट फॉर +2 आयन मीनिंग इट हैज लॉस्ट 2 इलेक्ट्रॉन्स, है ना, तो 1 इलेक्ट्रॉन रह गया, यानी कि हाँ, तो जो हाइड्रोजन लाइक एटम्स हैं उसके फॉर्मूलास लगेंगे यहाँ पर, हाँ? और हमको निकालना क्या है, एनर्जी ऑफ इलेक्ट्रॉन. और एनर्जी एज इन विच एनर्जी वी आर टॉकिंग अबाउट, द टोटल एनर्जी. और टोटल एनर्जी क्या है, नेगेटिव, ठीक है. तो रिमेंबर द फॉर्मूला फॉर हाइड्रोजन एटम, हाइड्रोजन का याद है, यू वुड बी एबल टू राइट इजीली फॉर हाइड्रोजन लाइक एटम्स ऑल्सो और हाइड्रोजन लाइक आयंस. अच्छा, व्हाट वाज द एक्सप्रेशन, टोटल एनर्जी एक्सप्रेशन देखिए, I'm calling it, let's say, TE minus 13.6, ठीक है, Z square by N square in electron volt. याद रहेगा ये, minus 13.6 Z square by N square in electron volt, ठीक है. Now if you were to ask, let's say, the kinetic energy of electron क्या हो जाएगा, तो ध्यान रखना kinetic energy is nothing but minus of total energy. तो total energy में देखिए माइनस साइन है ना, उसको प्लस कर दो, that's your kinetic energy. तो ये क्या हो जाएगा, सिंपली प्लस टाइम्स 13.6 Z square by N square इलेक्ट्रॉन, ठीक है. टोटल एनर्जी तो लिख दिया हमने, पोटेंशियल एनर्जी, राइट. सो पोटेंशियल एनर्जी क्या हो जाएगा, दैट इज गोना बी ट्वाइस ऑफ टोटल एनर्जी, ठीक है. इसे आप याद रख सकते हैं, इफ यू वांट आई विल राइट इट ओवर हियर. तो ये क्या है, ये माइनस ऑफ टोटल एनर्जी, और ये क्या है, ट्वाइस ऑफ total energy, okay. So double it, so this is going to become minus 27.2 Z square by N square electron volt, okay. All right, anyway, in the question they are not talking or asking about kinetic energy and potential energy, है ना. So we are only concerned about this formula, that's it. Just apply the formula, तो देखते हैं क्या आता है ये. So if you see third orbit is given, that is n is equal to 3, और z क्या है आपका, atomic number, right. So if you use that formula, minus 13.6 z for lithium is equal to 3, है ना. तो ये क्या हो जाएगा, z square by n square, that is z is also 3, n is also 3, both whole square, that is in electron volt. So if you solve for it, they get cancelled, so the answer is in electron volt, right. Very simple question, provided you remember the formula, right. You will get such nice easy questions also in your NEET exam also, right. So make sure you practice such easy questions because they help you remember the formula, right. So just practicing the hard or difficult problems is not enough, you also have to practice some easy questions every now and then, okay. So that's it, okay. And let's say here if I were to ask you sixth orbit, okay, sixth orbit में क्या हो जाएगा, then it will become 6 by 3 whole square, 6 by 3 whole square, that is 2 square, that is 4 into minus 13.6, that will yield you this thing, that is this answer will come for n equal to 2, okay. So like this options are given. Anyway, option 3, so let's check the answer slide, and yeah, so option 3 is perfectly correct, ठीक है. चलिए अगले पे चले. Moving on to question 31 now. ये देखिए, once again a really nice question from the projectile topic, ठीक है. अच्छा ये देखना, for a projectile motion in xy plane on some planet, ठीक है, the position coordinates as a function of time t are given as, position coordinates यानी कि position along x and position along y. So x and y coordinates are given to you, right. X coordinate over here and y coordinate over here, they are varying with time t, ठीक है, because they are given where x and y are in meter, है ना, और time t is in second, okay. Assume x is along horizontal and y is along vertical. The horizontal range of the projectile is horizontal range, ठीक है. So let's do something, horizontal range तो हम निकालेंगे ही. For the same question let's find few other things, है ना. ये निकालने के बाद let's find the initial velocity of the projectile, or rather the initial speed of the projectile, or we can also find the maximum height of the projectile, है ना. तो दोनों चीज़ें हम निकालेंगे, okay. The maximum height reached by the projectile or the initial speed, that is let's say u, ठीक है ना. अच्छा चलो let's come back to the question. it's given along x and y, है कि नहीं? It's given along x and y. अच्छा, अब ये क्वेश्चन करेंगे कैसे? ये क्वेश्चन हम करेंगे कैसे? फर्स्ट रिमेंबर ए रफ डायग्राम ऑफ दैट प्रोजेक्टाइल, ठीक है? सो लेट्स से for the same question actually multiple methods are there, है ना? So using the simpler method first, so let's say I have thrown this projectile like this at angle theta, ठीक है? The projectile falls like this, goes like this and falls like this, all right? X और y coordinates भी है, right? Let's say y is like this and x is like this, ठीक है? Y is like this and x is like this. अच्छा, now initially if you see at time t equal to 0, ठीक है? So let's write the coordinates, x is equal to y is equal to, x is equal to 4t, है ना? यहाँ पे मैं लिख देता हूँ, and y is equal to 4t minus 5t square, right? तो एट t इक्वल टू 0, ध्यान से देखिए, एट t इक्वल टू 0 कहाँ पर था ये? t इक्वल टू 0 x will become 0. We put t equal to 0, y will become 0. So that means initially, right, initially when we launched it from here, so what are the coordinates of that point over here? At t equal to 0, so their coordinates will become simply, है ना? So if you write down over here, t equal to 0, यहाँ पे coordinates क्या हो जाएगा? 0, 0. ठीक है? तो यानी कि it goes up and falls down. When it falls down once again and touches the ground once again, तब क्या हो जाएगा? तब x coordinate तो रहेगा, because now if you see this is actually your x axis, है ना? Because x और y आपका यहीं से निकल रहा है. This is your x and this is your y. Even though I have drawn it over there, remember this is your origin over here. ठीक है? So this is your x axis, यानी कि when it touches the ground once again, x coordinate तो है, but what is y coordinate now? Y coordinate equal to 0. So please remember, y coordinate is equal to 0. So what you can do, you can put y equal to 0 over here, ठीक है? So when we put y equal to 0, okay, so let me write down over here. What do you get? You will get 4t minus 5t square equal to 0. एक t आप कॉमन ले लो, आफ्टर टेकिंग कॉमन टेक इट टू द LHS, it will cancel out, है ना? 0 by t will become 0 only. So now what is left? 0 is equal to take 1t and disappear it. So this is going to become 4 minus 5t, है ना? If you solve for it here, 5 minus 5t, bring it on the LHS, this is going to become 5t is equal to 4. That is t is equal to 5t is equal to 4, that is t is equal to, क्या हो जाएगा? 4 by 5. And what is this t? T is the time taken to reach this point, है ना? Time taken to reach this point. So this is actually nothing but your total time, the time of flight, capital T, ठीक है? Or if you want, I can write it down as time of flight also. So in the question, if they are asked, find the time of flight, using the simple method you could have done. Okay. Now, how do we find the range? है ना? Because we are supposed to find the range, weren't we? This range. तो range क्या हो जाएगा? You know the time, है ना? Time को उठा के यहाँ पर substitute करो. In this equation, x is equal to 40, and you will get the value of x over here, right? So therefore, x is equal to 4 into t, 4 into, that is 4 by 5. ठीक है? Or if you want, I can write 4 into capital T. So 4 times 4 is 16, that is 16 by 5 meters. That's it. We got the answer, 16 by 5 meters, है ना? So this actually becomes your range. ठीक है? So this is your range, that is R. All right? Let me write down over here. So this, my dear friends, is your range. ठीक है? So let's come back, and therefore the answer becomes 16 by 5. ठीक है? Now something else I had asked, है ना, how to find the maximum height. अब देखिए maximum height, where would you be getting that maximum height? Maximum height तो यहाँ पर होगा, right, over here, which means this is your maximum height, h max, isn't it? H max. अब H max देखिए, how much time will it take to reach this maximum height? This is the point, है ना, where at which it is at maximum height. So how much time will it take to reach over there? Half time, right? Half time. If total time taken is 4/5 seconds, right? So this, remember, is 4/5 second. So that means how much time will it take to reach from here to maximum height? 2/5 second, है ना. तो यहाँ पर क्या है, t equal to 2/5. If you want, we can write it down. Let me write down over here. T is equal to 2/5 seconds. Therefore, when you substitute this t equal to 2/5 in these equations, in these equations, so when you substitute it in this x equal to, what will you get? You will get this reading, this x distance, and that is nothing but r/2, range ka आधा, r/2 you will get. Or if you substitute in this y equation, you will get this distance, and that, my dear friends, is your h max. Okay, so that's it. We have to do it and substitute it over here. So let's do it. तो ये हो गया number 1, हाँ. So let's find number 2. That is your maximum height. Use that equation. तो ये क्या हो जाएगा, 4t minus 5t square, है ना. So when you substitute 4 times 2/5 minus 5 into 2/5 whole square. When you solve for it, this will become 8/5. Now if you solve over here, this will become 5 into 4/25. 5 and 25 will get cancelled. So this will become 4/5, leaving us with 4/5 meters. ठीक है. So therefore, h max is coming 4/5 meters. ठीक है. What was the other thing I said we can find? That is your u. ठीक है ना, u. अच्छा, अब u कैसे निकालेंगे? u कैसे निकालेंगे? Remember, I also told you there are other methods to find the same question, है ना? See, you can find u from x and y directly, right? How? See carefully, focus on this x and y. U, remember, is your velocity at t equal to 0, है ना? That is at t equal to 0. Find the velocity expressions and put t equal to 0. That's it, you will get the answer. Okay? So let's see how we will do. Write the equations of x and y again. So x is equal to 4t, right? And y is equal to 4t minus 5t square. Okay? So differentiate this x with respect to time once. So dx by dt क्या हो जाएगा आपका? Right, so dx by dt on differentiating, this will become 4 only. 4 as in 4 meter per second. And what is this dx by dt? This we can say is your velocity along x direction. Velocity along x direction initially and finally also. Why finally also velocity along x direction is 4? Because there is no dependence of time over here. In a time, अब देखिए 1 second डालो, 2 second डालो, 4 will remain 4 only. Okay. Now what about this expression? Differentiate this one. dy by dt. What will this come? This becomes 4. This, if you see, t square differentiation is 2t. So minus 5 into 2t. This will become minus 10t. Right? Uy. Now how do we find uy? Uy, remember, is your initial velocity, that is at t equal to 0. है ना, t इक्वल टू 0 पर, ओके t equal to 0. So when you substitute this t equal to 0, this if you want you can write as Vy, but for Uy you substitute t equal to 0, this will become 4 minus 0, that is 4 only, that is 4 meter per second. Okay. So you have found Ux and Uy like this. So how do we find initial velocity u? It's pretty simple, right? Remember, Ux is along x direction, Uy is along y direction, they are both perpendicular, Ux and Uy, right? So the net velocity, the initial velocity is going to be nothing but vector addition of both, that is nothing but u square, you can write it like this, ux square plus uy square. Okay, so this is going to become 4 square plus 4 square, 4 square plus 4 square, that is 16 plus 16, that is 32. 32, or if you want you can write it as 16 into 2. So therefore u is going to become, you take square root of both, so this will become root 16 into root 2, root 16 is 4 only, this is going to become 4 root 2 meter per second, okay, 4 root 2 meter per second. Thereby we get the initial speed u as 4 root 2 meter per second, okay. There is also a second method using which we could have found this range, right? What is the second method? Remember that formula, right? The original formula of projectile, because they have already said, right, it's an equation of projectile, so what was the equation for range? Range, remember, is 2 times ux uy by that acceleration, acceleration along y direction, right? Because remember here you have no acceleration along x direction, isn't it? There is no acceleration along x direction, only acceleration is along y direction. In our original projectile, that is projectile conducted on earth, here we write 2 ux uy by g, because g is the acceleration along y direction, acceleration due to gravity, okay. And this one also here, coincidentally, this acceleration, if you could have found the acceleration over here, if you differentiate this velocity once again, you will get acceleration. Let me show you over here. Acceleration ay is nothing but differentiation of velocity with respect to time. Differentiate this with respect to time, 4 differentiation is 0, it's a constant. Minus 10 is minus 10 only, t differentiation is 1. So this is going to be minus 10 into 1, that is minus 10 meter per second square. It's pretty much or similar to that minus g we write. So when you throwing a projectile like this, what is the acceleration of that projectile is downwards. We write acceleration is minus 10 meter per second square. Why so? Because y axis, remember, is directed upwards. This is your x, this is your y. So y axis is directed upwards, but acceleration is downwards. So we will write minus 10, not plus 10 meter per second square. Okay. So in our earth case we write g, here it is ay. So coming back, you could have used this formula directly for this question, and ux uy, so we would have found over there ux uy we have no, right, 4 meter per second, 4 meter per second, है ना, उसको यहाँ पे डालिए, you will get the answer directly. Let's check. 2 into ux is how much? 4, uy is how much? 4, ay is how much? 10. Remember I am talking about magnitude, 10. इसको solve करिए, you can check, the answer will be exactly 16 by 5. ठीक है? So it's like a formula you can remember, है ना? You can check, है ना? Yes, this is coming 16 by 5 meters only. Okay, so this is another method or another formula you can remember. Okay. Another way of solving this question, using x and y, you can find the equation of projectile also. Equation of projectile, देखिए, what is the equation of projectile? let me write down over here, y equal to x tan theta into 1 minus x by r. ठीक है? So you have to eliminate time over here. Time कैसे eliminate करेंगे? Find t is equal to from here, t is equal to x by 4, take it, pluck it from here and substitute it over there. है ना? यहाँ पे substitute t equal to x by 4, here also t equal to x by 4. है ना? Then you can take x common over there, or you can take 4x common if you want. है ना? So you will get an expression like this. Inside the bracket 1 minus x by something, and that something is your range. So you can try for yourself. When you try, and please check once again whether you are getting range is equal to 16 by 5 meters. Okay. So three ways, or rather three different ways of solving the same question, but remember all these three are interconnected. And we are getting, remember these three are pretty much coming from the same formula. Alright. Okay, so I hope this question is pretty much clear to you. Guys, let's move on to the next one. Right. And 16 by 5 is our answer, which is correct. Chaliye. Moving on to question number 32. 32 is a very simple question. You have to remember the formula. Which of the following vector relation is incorrect? Which of the following is incorrect? देखिए, see the first expression. This is perfectly true. V is equal to omega cross r. If you want, we can check also. Right. So let's say this is the center about which a particle is performing circular motion, or rather, let's make it even more simpler, uniform circular motion. Uniform circular motion like this. Okay. Then at a point, velocity vector, this velocity vector is going to be in this direction, because the particle is moving like this. What about r vector? So velocity vector I have told you. What about r vector? R vector is the position of this point with respect to the center of this circle. So which means this is your r vector. Okay. Now how is the particle rotating? Particle is rotating like this, right? So place your thumb along the direction of rotation, or rather spread your fingers along the direction of rotation. The thumb will point in the direction of omega vector. So it's going like this. Omega vector is like this, that is out of the plane. Okay, so check whether this is correct or not. This expression, omega is out of the plane. So omega cross r, if you do, omega vector is like this, out of the plane. Omega vector cross r, so cross it with r vector. Right, spread your fingers from omega vector to r vector, encircle it like this. The thumb will point towards the direction of cross product. Right, that is omega cross r, thumb will point along cross product, that is v vector. It is given over here, and that is correct, right? When you cross it, v vector is also like this. So yeah, so this expression is perfectly true. Okay, this expression is perfectly true. All right. If you want, I can write omega vector over here. Okay, so dot circle meaning omega vector is like this, out of the plane. The reason why I gave so much explanation for this simple formula is because sometimes the expression may also be written as V is equal to R cross omega. Then that will become wrong. So you have to understand why this one is correct. Okay. So this is the correct formula. V is equal to omega cross R vector. Okay. All right. So this is correct formula. What about this one? This is wrong, right? Because torque is actually R cross F, not F cross R. This is wrong. What about the next one? Angular momentum vector L, that is correct. It is equal to R cross mv vector. mv is your momentum vector, p is your momentum vector, m into v. So R cross mv. So R cross mv is your angular momentum, R cross F, force, is your torque. So this is correct. Fourth option, F dot D, right? So this is also correct. W, remember, is your work done. So this is a scalar product, है ना? Well, these three are vector products because the answer is also vector. Anyway, so the answer to this question, which of them is incorrect? Option 2 is our answer. Okay. Let's check the answer slide. Right. Option 2 should be our answer. And if you check, yeah, option 2 is correct. Moving to question 33 now. Right. Moving to question 33. It's also a very simple question. No calculation, nothing is required for this. Let's see. A cup of tea is kept on a table. If it cools from, note the keywords, it cools from where to where? 80 to 75. That is, it has cooled down by 5 degrees Celsius in T1 minutes. Then they are saying it cools from 75 to 70. That is, again it has cooled down by 5 degrees Celsius in T2 minutes. Then we have to compare T1 with T2. We have to compare T1 with T2. So remember the concept of Newton's law of cooling. Okay. So the rate of cooling, that is minus dt by dt, we say is proportional to T minus T naught, or rather I am writing T minus T surrounding. That is difference in temperature between the body and the surrounding. Okay, T is the temperature of body. Okay, what is this signifying? The rate of cooling, because remember temperature is falling down continuously. Okay. Then for such questions we also use the short trick method, right? For short trick method, what do we do? Instead of writing in differential form, we will write like this, delta. Okay, so delta T by delta T is equal to, here we will write equal to instead of proportional. Proportionality has been removed. So a constant will come. That constant is called K. Here this formula will become T average minus temperature of surrounding. Okay. What is this? This signifies the same thing. Hai na? What does this signify? Minus delta T. What does that signify? If you want, I can write it over here. What is this? This, my dear friends, is your fall in temperature of body. Okay. And what does this signify? Time taken for that fall in temperature. Okay. What is this? K, as you know, is constant. This also you know, T surrounding. This is the average temperature of body, T average. Okay, average temperature. So if you come back to this question, come back to this question. So we say for the body to cool down, right? So let's say initially it cooled down by 5 degrees Celsius in T1 minutes. So if it were to cool down even another 5 degrees Celsius, the time taken would be higher. The time taken would be higher. Okay, so T2 is going to be higher. All right. Why so? That is the answer to this question is T2 more than T1. Why so? I am telling you why so. Right. So therefore, if you see, which one is our answer? T2 more than T1. Second one. Why so? See. Notice this formula again. Right. I told you this fall in temperature is same in both cases, right? That is 80 to 75 and 75 to 70. That is 5 degrees Celsius is the fall in temperature. K is same for both cases. Temperature of surrounding is also same. But this thing is not same. This T average is not same in both cases. And obviously this delta T, that is time taken, is also not same. Right? In first case, if you see in the first case, right? Case 1 and case 2. In case 1, what is the T average? That is, remember, I am talking about the T average we will use for that formula. And T average is how much? The average temperature of body. It is cooled from 80 to 75, right? So average temperature is 80 plus 75 by 2. 80 plus 75 is how much? 155 by 2. Okay. I'm writing it in fraction form only for now. If you want, you can convert it into decimal form. No problems. Okay. Okay. The unit is in Celsius. In case 2, it has cooled from 75 to 70. So average temperature will be how much? 75 plus 70 by 2. That is 145 by 2. Right? So 145 degrees by 2. So as you can see, from case 1 to case 2, that average temperature has also decreased. Right? Average temperature has decreased. And now if you come back to this formula, this is same, this is same, this is same. But if average temperature is decreasing, right? Therefore, if this is decreasing, we will say this whole thing has to decrease. Right? Because if this is decreasing, RHS will decrease. If RHS decreases, LHS will also decrease. Right? LHS will decrease when? Right? Initially, remember, for case 1, it was how much? This fall in temperature was 5 degree. Hai na? So 5 degree by time taken was how much? T1 minutes. Right? Just a minute. Time taken was T1 minutes. For case 2, this whole thing has to be even lesser, right? Because average temperature is less. Therefore, this will be further less when denominator has to be higher. Okay? तो आप denominator को बढ़ाएंगे, ये पूरी चीज़ घट जाएगी, right? Increase the denominator, whole thing will decrease. So therefore, we say time taken has to be more now than previous case. Okay? So therefore, time taken has to be more, that is T2 more than T1. Okay? That's all. Because T average was lesser now. Okay, so simple. That's all. I hope you got it. Let's check the answer slide. Right, so let's check the answer slide and just a minute. Okay, anyway, you guys go through this question once again, right? And you guys can check it once again. Okay, anyway, please go through it. All right, so moving to another question, right? Based on refraction. See here, what are they saying? A ray of light incident on a prism at an angle of incidence 60 degree. That is, I is given to you, right? Emerges perpendicular to the other face. So if it emerges perpendicular to the face, so what is the angle of emergence? Right, angle of emergence. So remember, whether it is angle of incidence or angle of emergence, we measure that angle between the ray and the normal. The normal we draw to that face, right? So the normal is perpendicular and they are saying the ray is also perpendicular. Therefore, the angle of emergence E will be equal to 0. Okay. Then the angle of prism is 30 degree, that is A, right? Then the deviation suffered by the ray is, right? So remember the formula for deviation, right? Direct formula, it is delta given to you by I plus E minus A. Okay. So that's it. Deviation is what they are asking. So delta will become, right? I is given to you as 60 degree. E is we know as 0 degree, right? And A, my dear friends, is 30 degree. right? So 60 minus 30 will become 30. So the answer is 30 degrees. Okay. Let's check the answer slide. And yeah, 30 degrees is our answer. Okay. Moving to question 35 now. Right? 35 is a very simple question based on Kirchhoff's law. Right? As in the two Kirchhoff's laws, which one is this one based on? Kirchhoff's junction law, not loop law. Why junction law? Because here we are only going to be concerned about this junction. Okay. So in the given figure, current in some branches of an electrical circuit is shown. Value of I is, value of I. So this is the I that is shown over here. I you have to find out. So we will use Kirchhoff's junction law. So what does it state? That the total current entering the junction is equal to total current exiting. Right? So I will write it like this. So current entering, okay, I am writing it in summation form, is equal to the current going out, right? Or let's write it like this, leaving that junction. This also in summation form. Right, so let's say current is entering via 3 wires at that junction. So you will write I1 plus I2 plus I3, and current is leaving via 2 wires. Right, so like this. I1, I2, I3, and current is leaving via 2 wires like this. I4 and I5. Okay. So here we will write I1 plus I2 plus I3 is equal to I4 plus I5. Okay. I hope you guys got a rough idea about this question. Now going to our question again, if you see and read, what are the currents entering the junction? What are the ones entering? Let's circle it. See, 7 ampere is entering, 2 ampere is entering, 3 ampere is entering, right? And that's it. So total current entering is how much? 7 plus 2 plus 3. That is 9 plus 3. 9 plus 3 is how much? 12 ampere, equal to the current that is leaving. Leaving ones are what? 4, I and 3. That is 4 plus 3, 7 plus I. Right, so this will become 7 ampere plus I. Right, let me write it in small I. So what is I will become? Simple subtraction, 12 minus 7, that is 5 ampere. And 5 ampere is going to be our answer. Okay. Let's check the answer slide over here. And yeah, 5 ampere is our answer. Alright. Moving to the next question now. Question number 36. It's once again a very simple question. The circuit has 2 oppositely connected diodes in parallel. Mind you that what current is flowing through the battery. Okay. Now if you focus on the diodes, first we have to find out which one is forward biased and which one is reverse biased diode. Okay. Achha. So forward biased diode, or call it FB, FB diode, right? So this, let's say I am drawing a simple diagram of diode like this. Okay, this is your P side and this is your N side. Okay. Now when P side is connected to higher potential, Okay, when P side is connected to, let me write over here, higher potential than N side. So at N side I can write lower potential. Okay, then we say it is forward bias diode, which means current will flow through the diode. Okay, current will flow through a diode, and diode is going to offer least resistance. Okay, and if you read the question, two oppositely connected diodes in parallel. Okay, and if we consider them as ideal diodes, we will say they are offering zero resistance, and in forward bias, if it offers zero resistance, we say it is like a simple plain wire. Okay, it's like a simple plain wire. And what if it is not an ideal diode? Then it will have some potential drop as it flows from this point to that point. Okay, a small potential drop, whatever it be. Now what about in the case of reverse bias diode, right? So this I am calling it as FB. FB is forward biased. In the case of reverse biased, okay, so I am connecting the diode in reverse. Alright, or if you want, you can let the diode be like that, connect the potential in reverse. This is P and this is N. Okay, so this we say is reverse bias diode, wherein this side will be connected to lower potential. While the other side, the N side, will be connected to higher potential. Okay. Now if you come back to the question, see which one is which. If you notice this diode D1, this is your P and this is your N, isn't it? N and P. Remember, this P is connected to which side of battery? P is connected to the negative terminal of battery. That is, P is at lower potential, N is at higher potential. Therefore, this is your reverse bias diode. Okay. So this, my dear friends, is reverse bias. Okay, so I am writing here reverse biased. And remember, in reverse biased, it will offer the highest resistance, right? And especially if it is an ideal diode, it will offer infinite resistance. Okay. Now what about this one? Here is your P side and this is your N side. This one, P is connected to the positive terminal of battery, while N is connected to the negative terminal. Okay. So therefore this we say is forward biased. Okay, so current will flow, and through this one no current will be flowing, because if it is an ideal diode, it offers near infinite resistance. Alright, so if current flows I like this, it will go like this. Okay, I and I, right? Because here no current is flowing and over D2 current is flowing. Okay, and since nothing is given, let's take this D2 to be an ideal diode. So it's offering zero resistance, right? So if you see over here, this circuit, 4 ohm and 2 ohm will be in series connection. Their equivalent resistance will become how much? 4 plus 2, that is 6 ohm, right? And the total potential difference, that is the EMF of this battery, right? That is 12 volt, right? If you want, I can write it as epsilon, or if you want, you can write it as V also. Okay, so the current in the circuit I will be nothing but epsilon by R equivalent, right? That is 12 by 6, that is 2 amperes. Okay, so 2 ampere is going to be our answer. Let's check the answer slide. And yes, 2 ampere is our answer. Any doubts, dear students? If you have any doubt, please mention them in the comment section, right? So I hope you guys had a great time. Yeah, so someone has commented, yeah. The answer is second option. Yes, yes Nishit, the answer is correct. Okay, very well. So I hope you guys had a great time, right? And keep practicing, keep working hard, and until we meet again with another good session like this. Thank you for watching.